my board and start to swing. The sun is shining on my back, the water's cooling down my arms as I lay down on the sea. When I'm flying through the tube, I don't think all I do is flow. I don't care it if we'll land, 'cause I'm right here at this moment. No other place I want to be than the waves at the beach of the sea. No more pain and sorrow, I'll be back tomorrow.
So today we are talking to Peddle, another known Commodore engineer for ships back then in the 70s. Hello, Chuck.
Hey,
Hi there.
a lot more than chips, right? It was
Yeah,
my
a
team.
lot more.
My team. It was my team that did everything Commodore did ever. All of the computers that Commodore made up until the Amiga were made by my team, and then they bought these guys from Atari who did the Amiga, and then of course they followed up on the Amiga for a long time.
But you are most known for your ship that you did, 6502.
Well, I don't know. I think I'm actually probably more known as because of the personal computer. I think technology people may know more about the 6502, but you know, you must understand that we created the market for personal computers, right? But we actually not only created the first personal computer, but we also created the market for it. And then we created the second market with the VIC-20. Sinclair had actually started that market. And then the 664 was a unique product in its own right. I came up with the concept every home has at least 2 computers, but that was everybody thought I was crazy when I said that. No, and actually everybody has their own computers, right? I think I told you the funny story, but I'll tell it again so it puts that in reference. We did the original Commodore, and we were just starting the company, just starting the manufacturing. Commodore as a company was a company buying calculators from Japan, so they had no manufacturing capability. So we actually they had some manufacturing building watches before, but they didn't have anything. So we had to create the manufacturing from beginning, just like we had to create the market and the product and everything. So we were in the process of bringing the factory up to speed. And because of that, we would take people's payment in advance. And when they paid us, they then went into a queue, right? And a queue was as long as, lots of people paid in advance, and we were running slow. The queue got longer or shorter depending on our ability. And we finally caught up a year or two later. Actually, we caught up when we hired a guy by the name of Tom Mitchell, who ultimately started Seagate, and then started another company and is now a big manufacturing guy in Asia. And he was the one that really put the manufacturing in place. But during this period, we were going to shows. Computer shows of various kinds were springing up in the Bay Area. And so we went to this show, and I made my engineers, I always had my engineers go to the first show where their new product was introduced, and they could listen to everybody telling them how great it was, right? It really made it a very positive experience for them. But I wanted them to learn about the problem of making a good product. And so they had to go back the next year and listen to all the customers' complaints about the product that they built, which is really useful, right? And so we're at this show, and this lady comes up to us and said, "You really have to help me." And we said, "Well, yes, how do we help you?" "Of course we help you." And she said, "I've got to change my priority." And I said, "Well, we legally can't do that because because we were taking money in advance. We had to put them in proper order." And she said, and we said, "Well, what's the problem?" And she says, "Well, I bought a pet, and my whole family loved it, including me. So what we did is we drew time for who gets to use the computer when. And my time is between 2 in the morning and 6 in the morning. so, so that was the case of the home having more than two computers, or her having her own finally. And it it showed that there weren't so many people that knew they needed them, but once they got them, then really and truly, a lot of people bought multiple from us, and ultimately they bought multiple because they bought MS-DOS machines, and now they buy smartphones, right? But it was when I made the prediction about everybody was going to have two computers, probably less than 5% of the people had computers, and everybody thought I was crazy. I was wrong, right?
But actually, you were first working at MOS technology, who was bought by Jack Tramiel back then from Commodore.
Yeah, fundamentally, I think I told you this, but I want to brag about it a little bit for myself and Bill Mensch. There was a team in Motorola started by a guy by the name of Tom Bennett, who had the idea behind the 6800. Okay, and the reason they did that is because they had spent all this money on a company called Viatron, which was a big fraud company that was created to tell everybody you could have your own CRT. And so Motorola had invested all this money and all this technology, and they'd brought their process to a certain level. And Tom was out of maybe NCR, anyhow, a place that made calculators. And he had just thought that what would make a good computer was to take a calculator and make a computer out of it. And I don't know if you realize it, but like the 4040 that everybody thought was maybe like the first personal computer, it wasn't. It was just a calculator. But because there were like 6 or 7 people did high capability calculators that were sort of personal computers. But my definition of a computer is something that has control as its primary function, not arithmetic as its primary function, right? And so Tom convinced me that I had started a company that was designed to make the cash register, online credit verification, automatic gas pumps. We started that company in 1969. And so we had a working demo built of this thing, but it was using shift register memories and TTL logic, MSI logic. And so I wanted to have a chip that did more. And so the guy, Tom Bennett, convinced me to go to work for him and to design the chips I wanted to do my cash register, because I was a guy that knew why we were doing it. Most of the rest of them were just thinking they were doing a computer, whereas in my case, I had a specific goal. I wanted to make something that you could make a cash register out of. You could make a credit verification. You could make a gas pump control. You could make a copier. And so I had a clear description of what I wanted. But I came into the 6800 program too late to do anything more than add some functions. Like I fixed the interrupt. I'm the one that we put non-maskable interrupt into the 6800, which is the first time anybody had done that. And I explained to everybody why you need non-maskable interrupt if you're going to do control. And and I fixed the interrupt structure. So the 6800 was there, but it was expensive, right? But I knew that we needed the ability for the computer to talk to things, right? And so I took on the job along with a guy just out of university by the name of Bill Mensch, and we designed a product called the PIA, which is the fundamental patent on I/O. It had edge detecting. It had the ability for any input to be an input and output. We had 2 different kinds of inputs so that you could have high capacity current and low current inputs. It was done as the device that let a computer talk, the processor, to talk to somebody, right? And to control things. And we consider that to be the most important invention in the personal computer industry, more than the 6800, even more than the 6502, because without that function, which people have since copied and licensed Motorola, and all the computers today have functions. As a matter of fact, We had a previous conversation about the fact that a lot of people were buying assembled computers now, where the I/O is there, and it's less computing capability and more specific function. But what they've done is just pack the I/O onto the same chip. And so that product we did at Motorola, right? And with that device plus the 6800, I was the only guy inside Motorola that knew why we'd done a computer, right? All these guys thought they were doing a mini computer. And so I wound up being the one that introduced the product to the field by going to the various field locations, and I signed Hewlett Packard and Tektronix and Ford Motor Company and all these companies to the concept of a computer. But I always did it based on the I/O devices, right? And so it was funny because it was so new. We'd gotten some good write-ups from the technology people, right? So the magazines, electronic magazines, which most everybody was reading at the time, were saying you really need to learn about microprocessors because all of a sudden they realized you could do something with them. So every time I would go to a company to make a presentation, they would actually bring the smart guys from 2 or 3 other divisions in. And so I would have this room full of really smart people, right, who wanted to know what it was about. And so I would take them through and explain how you use it and everything else. And always at the end, every time, the guys would say, you keep talking about this will replace MSI logic. And I explained to them how it can. And they would say, but the microprocessor is too expensive. And so I would say, okay, guys, the reason the microprocessor is expensive is because got a lot of functions. So let's sit down and define the minimum functions you're willing to live with to get a cheap computer, cheap processor. And they would always come up with about the same set. And it turned out to be the same set that Carnegie Mellon had derived, that was later the PDP-11 and PDP-10 were based on that same study at Carnegie Mellon as we did. And they always came up with the same kind of, this is the instructions we want, and we want better addressing. And it turns out that was the real secret to all of that, was the better addressing. But again, better addressing was so they could control more devices, right? Because a lot of the control applications are not ROM or RAM limited, right? They're often, my pinball game was many PIAs because a lot of control in the PIA in a pinball and not a lot of logic. And what happened is, I have to tell a story because it really is true, and there were some lies later passed on by Motorola. We knew that people wanted this computer because these smart guys every time came up with this set, right? And Motorola's management thought they were building a mini computer. The guys who had taken over, they took the project away from Bennett and handed it to some guys that wanted to make their own computer. And so they sent me a formal letter from the attorneys saying that you have to stop working and selling the concept of a low-cost computer, right? We're going to only do the 6800. And I wrote them back a memo that said, as of this moment, I will not work on any microprocessor for you again, because I am going to go do that microprocessor, and you just did what is called in the industry as product abandonment. So you can't patent it, right? You can't claim it as yours. And we then went off and found a company in Pennsylvania. And the reason we found that company is the guy that was running that company was the guy who actually worked from a General Electric company, and he did, you're too young to remember this, but checks used to have magnetic ink recording on the bottom. Did you know that? Now it's all optical, but at the beginning, the way they automated checks is they put this magnetic ink recording on the bottom, and this is a project started by Stanford Research Institute, and then they turned it over to GE. And the guy who did the first check system was a guy by the name of John Pavin. And he then went on to be a manager in GE, and then he went off and went into a company called General Instruments, yeah. And he started doing process development there. And So he and his 3 or 4 guys from there had spun out this company that made the world's best calculator chips. Right, they were higher function, and he had invented a couple of things. Like he was the first guy to use Perkinelmer projection masks. At that time, we were still making, everybody else was making a mask and running it for a while, burning it up and everything. And by doing this thing with projection alignment, these new projection alignment, which of course everybody uses now, those things were, he had started that, right? And he developed, and so, but because he was an ex-computer guy, he really understood why the microprocessor made sense, right? It was an easy conversation with him. And one of his other managers, who also was one of the partners, he also understood that this is what people really need, is this low-cost computer or microprocessor. So they funded us, moved our team across the country, and we did it for this company, which was now this is a calculator company, was making their money in calculators at a time when the Japanese swapped the calculator business from P-channel to CMOS, right? You don't, maybe we're tracking that business, but there was a time when all your watches were made with LEDs. The electronic watches were made with LEDs. And so the first thing they did is the guy in Japan came up with the LCD watch, right? And then they took a look at that and said, well, we can make LCD calculators. So what they did is, in order to do that, you have to have a CMOS process, right? So
the watches, were first, and then came the calculator.
Yeah. The first thing they did was a guy in Japan that actually did our first Epson computer with us was the guy who invented the watch, right? And then at that point, in order to do the watch, you had to do CMOS, right? So they developed a CMOS process, right? And that was about the time the Japanese started making their own DRAMs, and the Americans thought they had that business locked up, and ultimately the Japanese took it all away from them, because the Japanese were much more focused on process quality than the Americans, right? The Americans would get something that worked and be happy, and the Japanese kept refining it, right? And I can remember meetings with these guys at MOS Technology, some of the engineers who were looking at what the Japanese are doing, and they said, well, they'll never get there in the memory business. And of course, they were just totally wrong, right? But the point is that at that point, these guys had the best P-channel calculators, right? And the Japanese hadn't quite matched them because its CMOS was still, not able to do as dense a circuit as they could make in P-channel, but it didn't last very long. So they went from making pretty general calculators into being really specialized high-end calculators, and it was ultimately going away. And the microprocessor was supposed to replace it, and would have, except for the fact that the guys who were funding them, a company called, I've forgotten the name. I'll get it in a minute. That company decided that they didn't want to be in that business anymore. There was no carryover. So the partners wound up with the whole business, but not a lot of money. And Jack Tramiel at Commodore had the previous year, in order to compete against the Japanese who were in Texas Instrument, he had found local P-channel manufacturing and made some of his own chips run. But what he decided he wanted to do was have a vertically integrated company with all of this capability. And so he bought MOS Technology, not for the computer. He bought it because they had this high-end calculator capability and had their own processing, right? But during this period of time it was developing, John Pavin and we had a goal for the 6502 is it had to be single voltage power supply in order to be able to replace logic. And he developed the process independently of anybody else that made a 5-volt single voltage process. And just shows how brilliant the guy was, right? Because he was able to compete with Grove, right, in what he did.
So let's summary a bit. So actually you started working for Motorola first, then you had the idea of a microprocessor, and Motorola said, no, not our business. Then you went to MOS Technology.
They said no, not a low-cost microprocessor.
Okay.
Limited function, low cost, no, right? even though they had the PIA at that point. And because they didn't understand, right? The guys that were making that decision just didn't understand what we were trying to do.
Okay.
So the MOS Technology, the manager at MOS Technology understood two things. One, why we wanted to do the computer, and two, how to make a process that would make it better, right? The 6502 was the first low cost, because we were trying to make low cost controllers, right? And so you had to be single voltage and all that in order to be able to make that. So we developed all of that simultaneously over about a 9-month period. And when we introduced the computer, we had this idea. This company has no marketing, right? They were only selling to 2 or 3 guys like Commodore. So they have no market presence at all. Then MOS Technology doesn't mean anything to anybody. So in order to get brand name recognition started, right, what we did is we took ads in the local engineering papers, right, where we offered to sell. At that time, Motorola was selling quantity one, I think it was $250, and Intel was like $250 for one chip. So we said, come to the West Coast Fair, and you can buy one of our computers for $25, personal, right?
So the chip was $25. That was the low-cost chip then.
Yeah, and we put it into the Atari games at a lot lower price than that, right? But the point was is being able to buy one for $25. We were exactly at the right time, because all of the people who were going into microprocessors were looking for a microprocessor that was less expensive, and being able to buy one, literally they would come up to the suite, and my wife would take one out of this big bin that we'd made up, which about 3/4 of it didn't work, but the top ones worked, and she'd just take one out of there and put it on there along with the books, and they would go away. And they had actually bought a computer for a microprocessor for $25, and that's where Steve Jobs got his first his microprocessor.
So you even produced for Apple.
Oh yeah, no question. Steve Jobs came by the booth and bought one, and went home to talk to Woz, got Woz to work with him at night to do that was the time that Sooting had done this thing called Digital Group, and they were starting to sell a board computer that you kind of built yourself, and that was Apple's idea, right? That was Jobs' idea. He'd seen that concept and he wanted to duplicate it. So they took the 6502 and they went off and designed their own in the garage. And it didn't work, so we went in and helped them make it work in the garage. And then they started selling them, but they only sold a few hundred, right? Because there were enough, between studying and a couple other people, there were enough people making a computer that you could build for yourself to satisfy that market. It was, I don't know if you've ever heard of a company called Heathkit, but Heathkit used to sell you, you could build your own audio system with this Heathkit products. They would ship you all of the pieces, and that's how they sold the computer. They would ship you the pieces and a board, and you'd make it up yourself. And so there was a classical market for people that wanted to do that, including the guy by the name of Bill Seiler, who I met when I was doing the pinball game. I was doing the pinball game and designing a controller for a copier in the same city. And I was working at night, and he came in with this board he had built up with Sooty, and he got it working, and what it did is it played the Star Spangled Banner, right? And then I said, well, now what are you going to do with it? He says, I don't know. I was happy I built it. I got it to work. And Bill Gates remembers Seiler for another reason. Gates had gone with this company in Albuquerque and started making a BASIC that was people could buy. You bought the BASIC. And so what would happen is these hobby clubs had formed, and they would buy one copy of the BASIC and then distribute it to everybody else. Okay, so Gates started complaining, I can't make any money when you guys copy my technology, but he couldn't ship them a product that wouldn't load, and once they did that, it was easy for him to copy. So Seiler got a freebie BASIC. And when he was done making it work, he decided he felt guilty. So he wrote to Microsoft and said, I want to pay you for this BASIC, which I've been using. And he was the only guy that ever did that. Bill Gates remembered him as a guy who was honest enough to say, here's my BASIC. Which is why when we told Gates we were going to put the BASIC in ROM, we were able to give him a fixed code, and he now knew that people couldn't steal it, right? And ultimately, that's
interesting. By the way, BASIC celebrated 50 years last year in 2013.
And I think you told me that they finally gave credit to the guy at Dartmouth that invented it, right? Everybody thought Gates invented it, and he didn't. This guy at Dartmouth invented it, and GE, we were the first users, and I think I told you, we were actually using BASIC. We made the computer called the BASIC computer called 225, and we were making jet engines with that, with engineers writing their own programs in BASIC and making jet engines, right? And BASIC suddenly was becoming important, and the most important thing about BASIC, and let's finish the 6502 story. Okay, so we finished the 6502. We had it ready to go. And we had designed, actually a suggestion of one of the engineering manager at NMOS Technology. His point was, is if you're going to ship a low-cost microprocessor, what you really need to do is make a chip that has RAM and ROM on it, and we make both of those, and I/O, so that the guy can have a complete system in 2 chips. Right? And that was what we sold Atari, right? The guy in Grass Valley, California that I went up and visited, he convinced his management that they would go with a microprocessor as opposed to doing a custom chip, but they had to do a new video interface chip. And he actually contracted with our second source in California, a company called Centertech, and those guys developed it. And the guy that developed the thing for Atari ultimately was the guy who created the Amiga. Right? He went on to create, but first thing he did was create the interface. And the Atari, he was really doing chip design, because this guy named Joe LaCour and the other guys at Atari were really pretty smart guys, right? And they had made all of the games, the arcade games. Did you ever play arcade games?
Yes, I have an arcade right behind me.
Yeah. So they that was how Atari was making their money, right? They had
the Pong machine first.
No, they did the Pong machine and put it in bars, and literally it was the quarters from the bars that were paid that paid for Atari, right?
That's exactly the story. Yeah, they didn't think they would earn any money until they got a call that the machine was broken. And that was not broken, but there were so many coins.
Yeah, they had them. So what happened to them is this company in Florida that Silo worked for called Allied Leisure thought it was a great idea, and he was much better because he was making these other games. So he was much better at making the games for the bars, and he ultimately took over the bar business away from Atari. But by that time, Atari had moved on to Tank and Night Driver and that stuff, and so they were making games, arcade games that were very superior. And what Silo was actually doing was they had Allied Leisure was an old school, right? So their stuff was electronics plus a lot of mechanical things, and he was making car noises, right? That was his job, was to make the car noises in the arcade games better, right? But the point is that Allied Leisure had kind of thrown Atari out of their business, but that was when Atari did the Pong for the video game that went to Sears. And I don't know if you remember that story, 1 minute story. They had this new game called Pong, right, which is a pretty dumb game, but it was the first one. And the people that were in the consumer electronics part of Sears said, we don't want it. And the guy, every department in Sears at that time had to create a store pull-in, right? They had to run some kind of a special, that made people come into the store so they would buy everything else. And
maybe we should mention that in Europe the game is also known as Tennis for Two.
Is that right?
Yeah, tennis.
Oh, tennis
for
for
two.
two. Okay, yeah.
So
Well,
just let people
anyhow,
know.
yeah. So they went to the one guy in the sporting goods department had offered them cheap basketballs or something or other, and they didn't think that was much of a draw. So he says, "Listen, what I'm going to do is I'm going to put this game in my store, and I'm going to tell people they can come in and buy this game at a cheap price." Well, turns out that was the beginning of that industry. Everybody came to the store to buy the game, right? And totally, Atari just took off, right? And so now at this point, they've done very well, but it's a kind of a dumb game, right? So what they wanted to do was to make a more programmable game because our controllers they made were pretty sophisticated, right? And so
The analog paddles, you mean?
yeah, the whole thing, yeah, all of that stuff they had to invent, right, for the TV. So they had all this stuff, but they needed more logic, right? More something so they could make Tank and they could make Breakout and all that stuff. And so and they made those. They put the logic. They took 6800s and put them into the arcade, and they put a lot of stuff around them, and made a nice arcade game. But they knew that was something they wanted to translate into the home games, right? And in order to do that, they had actually charged the guys in Grass Valley with coming up with some new chips, and he said no. He says I want to use this low-cost microprocessor, this RAM-ROM I/O chip, plus I want to create a video interface chip, which Cinetech then did at his direction, and they kept this thing totally secret, right? They told what they did is they went to every microprocessor company, and they actually put a team in place that was designing the microprocessor for the 6800 to go in the Atari game. And other guys were doing the 8080, right? And they had these guys convinced, each of the each of the semiconductor companies, that they were going to get the business. It was the original one, right? Remember, there was an 8086, which was the 16-bit version, and the 8088 was the 8-bit version. And that was second generation, just like the 68000 was second generation from Motorola. No, this was the first product that Intel had, right? And it didn't do very well. The Z80 was done by the same team that did that. You must have heard about Z80 because that was the basis for the Radio Shack machine. And that was the same guy, Fagin, that did the work for Intel, and he went off and spun off his own company and kept it going for a long time. Anyhow, but the point is that, and so they had a Z80 team too. So they had all these teams designing the next Atari product, and all these guys were convinced they're going to do it. And then in the fall, they announced that we were going to be the computer, right? That they announced the product based on our computer. Next day, Motorola sued us. They were so mad. They sued our company and claimed we stole it from them. We had to spend a year proving that we just, the architectures were totally different.
That MOS technology stole the idea from Motorola.
We had an ex-Motorola team, and we've been very careful about doing it. And I had this piece of paper, right? But it didn't matter. Motorola was so angry about losing the Atari stuff, they sued us, and it took us $1 million to prove they were wrong, right? And that happened. Big companies beat up on little companies all the time. The net effect of all of this, the suit, paying the lawyers, paying all of this stuff, is that Jack Tramiel decided that he would buy that company, MOS Technology, right?
And of course, he needed the money for the suing and stuff, or because they were sued.
They needed the money. It was their only personal money, right? And they had stretched themselves, and he made them a good offer, right? And they were saying, they could see the calculator business was narrowing, right? And Commodore had enough of a market that they could keep selling for a while, but they could see that it was going away. And they also knew that the microprocessor thing, even though we were selling a lot of things called a Kim1, which we created, right? But we were selling a lot of them, but even then it wasn't enough to carry the company, so they decided it was better off selling it to Commodore.
How did Tramiel learn about MOS technology?
Oh, because they made the best calculator chips. So Commodore had always been a customer, right? Because their calculator chips, because of their ability to do this maskless changes, because this process change they were able to make perfect masks, and because of that, they could make a much denser chip, so they could put a lot more logic in. So the scientific calculators they made were top line, right? And because of that, Commodore was already a customer. But the guy who convinced him was a guy by the name of Andre Souzan, that he should go buy the company because they had contracted a local manufacturer in Silicon Valley to make the chips the year before, because before they were buying their chips from Texas Instrument, but Texas Instrument was trying to kill them, right? Texas Instrument, and they tried buying some stuff from the Japanese, and same thing. Everybody who was making calculator chips wanted to kill the customers, the intermediate customers like Commodore, and so he went into vertical integration. He believed in vertical integration. So he bought Commodore as a vertical integration for calculator companies. But Andre Souzan, who I'd actually worked together at a previous company, he knew and understood what we were trying to do, right? He really did. He was a very smart guy. So he convinced Trammell to buy the company, and then he convinced Trammell, with the help of a contract that we had, a potential contract from Radio Shack, he convinced him to let us go build the PET, right? And the name PET was created by this guy, Andre, because he lived in a place called Los Gatos, California. And that Christmas, we were doing it in the fall, that Christmas, this guy started selling what were called PET rocks. And he would send you a rock with a little note, and you'd pay $25, and it was your pet rock, right? And he thought that was such a wonderful idea. He called the computer your pet computer, right? And we ultimately, in order to justify the name, used personal electronic transactor, right? And inside MMOS technology, it was called Peddle's Ego Trip, right?
Interesting, yeah.
And the funniest thing is this guy was French, right? And he'd come up with this name because of the rock, and we were doing okay in the United States. When we went into France, he couldn't call it pet because that is a sort of like P, right, in French.
Okay.
So they had to call that machine P-E-T, right? P-E-T, not pet, right? That's how they sold it. It's because otherwise it had this dirty sounding name, right?
Oh.
And he was French, and he didn't think about that, right? It was just fun. Anyhow, the point is Andre backed the project, and that was when we got this magic story that you hear about. Apple tried to tell us how to do it and all this sort of stuff. What happened was we were on a very tight deadline to make the Consumer Electronics Show in January because Radio Shack wanted to see this computer. And Radio Shack was the company that said it should be in a complete box, right? We don't want any assembly. We don't want anything. Just put it all together, put the screen in and everything else. And that was matching my idea too, because I had talked to everybody I had talked to that was looking at kit computers were people like programmers or accountants and everything. And they said, we don't know how to build anything. We don't want to put anything together. Give us a box that runs BASIC. That's what we want, right? And so, and Radio Shack said the same thing because they were in the assembly business anyhow, but they wanted to make this computer. So we had to make a computer that was integrated in time for the January CES show, and we didn't start until October. So we're under real pressure, right? So rather than designing our own board to go in this demo, we were going to buy a product. And we originally went to Apple because Apple was working on their second generation with King Apple II. And Andre thought, it's a little small company, they've sold maybe 300 or 400 machines, we'll just buy them. And there was actually a negotiation between Jack Trammell and Steve. And Steve wanted a lot more money than Jack wanted to pay for just bringing a couple engineers in, so they didn't get along. But in the course,
so actually, Commodore tried to buy Apple.
They discussed buying Apple because of Andre Souzan, right? They suggested that was a way to get it done. Peter Sainal, who was the guy who actually helped me put the thing together, he had actually found one of our customers. See, we were selling 6502 to a lot of people. He found a customer, had a board that would work. And he said, we don't need to buy from Apple, right? And it turns out that when I sat down with Woz, there was actually a meeting where they came over to their place, and Trammell didn't want to talk to both Woz and Jobs because Jobs said he was the decision maker. So I took Woz off in a corner, and we started arguing about what the personal computer ought to be. And Woz is a really hobbyist. There was a group down at the Sanford Recycling Center, and it was one of the most powerful computer clubs in the West Coast, and he was involved in that, and he totally designing his next computer for those people, right? So he was a pretty smart guy. So he had done a version of the 6502 code that he called Suite 16. It was like a macro assembler, right? And he had done Suite 16. And he said, this is what we want to do. We want to make this computer that has good graphics and we can hook up to a TV and we're going to give these guys Sweet 16, and the people that he was talking to would be happy to program it because they were really kit guys. And I said, but Waz, that's not what we're doing, right? We're designing a computer for people who already know BASIC and know why they want a BASIC computer, right? Because there were literally a few million of them around the United States, right? And they had learned it in school, they'd learned it in timeshare somewhere, and they already knew they wanted one, right? And so there was never any discussion about them teaching us how to make the computer, right? But there's all kinds of stories that Woz actually said that he thought we were doing a bad machine, he did a better, and all that stuff, and none of that happened, right? It just wasn't happening. We took this board from this other company, built up our demo, barely got it working at CES to show John Roach. Jack and John Roach couldn't get together because John Roach wanted to buy the computer, but Jack wanted to sell him lots of calculators, and by that time the LCD calculator had come on, and Radio Shack wasn't going to buy any more LED calculators, right? And so they couldn't agree, and John Roach then went off and designed his own, right, the Z80, and at the same time Apple was finishing theirs, and we already had ours done, but we had to then turn it into a computer, right? We had used a board and made it up and everything, so we had to do that. And we actually, all of us got our computers ready to show. And there was this really smart guy in the Bay Area, and I don't know if you've ever heard of him, who came up with the idea of having a show only showing personal computers, right? And he put it in one of the convention centers there. And in order to go into the show, you had to pay $25 to go in and look at all these guys, maybe computers, right? And he couldn't turn people away. I mean, they couldn't handle the lines and everything. And I took Jack Trammell over to the show, and he saw, here's all these guys just standing in line to pay $25 to go in and see, right? And the Radio Shack came up with the same conclusion. Forget it, we're going to make this product happen. So he totally backed us at that point. And we actually then took the computer to Dallas, it was a big show called WestCon, which is a computer show, and so the second floor is all these big computer guys, and they think a place called a boutique under the place, and they weren't sure who would be in the boutique. So we came in and we were ready to start selling at that show. And so we actually had a demo, 2 or 3 machines, and my wife was then sitting there taking orders, and the statement was, you pay us for the full computer today, we'll ship you the computer in 90 days, or we'll give you your money back, right? And there were people standing 10 deep arguing about who was going to get the next line, one in line. Totally chaos, because it was time, right? People were ready to do this. And I took time, because I was still out of the computer business. I'd been in the big computer business. So I took time to walk up to the second floor, next to the last day of the show. And there was nobody on the floor. Nobody was going around and looking at the exhibits or anything else. Everybody was downstairs buying their own computer. It was totally, this was the time, right? And so we got totally sold out, right, for months, right, in that show, we had barely finished the product in time, right? We had just gotten the tape system working. It was really a tight squeeze, but there was nobody else around during that time. And right after, we had actually gone to a Consumer Electronics Show with a version that sort of worked, and this one guy walked up and said, here's a check for $25,000. I want your first computers, period. Stop, right? And he became one of the biggest computer distributors on the East Coast, right? Because he started first, right? And So we were definitely way out ahead of Apple and way out ahead of Radio Shack, because Radio Shack actually went to the show in the West Coast, figured out what they were going to do, and they went out and finished their own machine after that. And the Apple came out with Sweet 16 and failed, right? And because our machine in BASIC had a good front end, I put a good user-friendly screen on it and everything. So it was the thing that people could use, right?
We should say that BASIC at that time was already run for 10 years.
Yeah. But not the BASIC we were selling. We actually wrote all the I/O instructions for BASIC, extended the character set. I don't know if you've ever looked at the ASCII character set, but it still has our card symbols in it. ASCII was 128 bits, 128 character set out of 256. So we took the second 256 and took it over and made it ours.
ASCII, if I'm not mistaken.
Yeah, whatever. But if you look at today's ASCII, you'll still find some underlines and some hearts and diamonds and everything, because they've replaced them over time, but they haven't replaced them all yet, right? And we put a thing which was defined by HP called a GPIO bus on, so you could control peripherals. They had designed something for their calculator business where they could control multiple, and I don't know if you know it, but if you go into a hospital, you get this HP setup, and it's controlling, there's always a computer that's controlling all these instruments and integrate, and they're all using this thing called a GPIO bus, right? It was a bus that Tektronix, everybody standardized on. And I put it in because I wanted to give the computer dignity, right? And by the way, we sold some to people that used them instead of HPs, but more importantly, I put the I/O instructions in, and we agreed, the guy working with BASIC, who had written the BASIC for the 6502, agreed with us that they would put our extensions in, right? And so that we could build our own screens and do all that stuff, and that they would give us a fixed price, and then, but the agreement is they could then sell it to anybody else, right? And so first Radio Shack came by. No, first Apple came by because they had Sweet 16 and it just wasn't selling. So Apple went to them and said, we want to buy the BASIC, and they, Gates quadrupled the price we'd paid, and they paid that, right? And then John Roche had put a tiny BASIC in because he knew we were putting BASIC in, but he put this thing called Tiny BASIC, which wasn't effective. And so he came to him and said, I want the BASIC. And he was the first guy to suggest to Gates, don't charge me $250,000 or whatever the number was. I'll give you $2 a machine, right? And Gates said, no, I want the money. Okay, and it wasn't until Kenichi came over from Japan and convinced Gates that selling them with a license was better than taking a lump sum, right? And Gates had actually learned that from the Japanese, and then when IBM came to him, he was prepared to offer them a licensing fee. And then he went to all the rest of us and said, here's my product, which I'm selling to IBM. If you want to have the same product, I'll give it to you for a per machine price. And since then, of course, they don't sell anything outright. They sold. We had a limit on our sales because we were the first guy to sign up. We'd put an upper limit on the amount that we were going to pay him. And a guy by the name of Alan Sugar, who was making a cheap machine in Europe, walked in and said, I'll pay you $5 million one time, and they took that deal. And, but aside from that, after that, Microsoft never sells anything now outright. You don't buy anything from them, you lease it from them, right? Whether it's home.
Well, that is how Microsoft became rich.
That's I'm saying, but that change was made from the time Radio Shack offered it till that time, right? So anyhow, the PET, particularly in Europe, did extremely well, and the Europeans said, it's wonderful having personal computers, but we want a computer that's better, right? And so we put the printer on, we put the dual floppy disk on, and we made a machine called a CBM, which was a more business machine, right? And people were buying it for that. And we knew that we wanted to go and build what became the MS-DOS machine, and that the 6502 was out of steam, right? There was addressing space. You know, it was never designed for that, right? It was the only reason the 6502 worked at all was its basics in interpretive language, right? So you don't need, you know, you're never ahead, right? You're never doing anything in terms of subroutines and everything. You do one basic statement, interpret that one, go to the next basic statement. So we could get by with a 256 byte stack, and we could get by with all this stuff, but you couldn't do it in a real machine. And so we wanted to go to an upmarket machine. And at the same time, Clyde Sinclair had come out with this product called this, what the hell was it? Anyhow, it was a machine that made him a knighted guy, right? Because they sold a lot of them. But the machine was so bad that once, I used to tell everybody that once you knew what you'd bought, you knew you'd made a mistake. Okay? And Seiler had come up with this idea for the VIC-20, right, earlier, because we were waiting for the better I/O device to make the C64. So Seiler said, let's do this interim, and Trammell had rejected it, but after he saw the Sinclair, he accepted it. We had to do some internal politics. And then that's when MOS Technology, and we built the first VIC-20 and did all the design and got it done. And we had the C64 ready to go except for putting the I/O device in. And then we left Commodore, right? And Jack Trammell threw us out.
If I'm remembering the story right from Brian Becknell's book, that actually the subroutines for the floppy drive were filled with bugs. That is why the designers had to slow down the process speed of the floppy disk, so it would even work. Otherwise it wouldn't.
No. Who said that?
Wasn't that in a statement in the book that the routine was still trouble? And this is why the 1541 is so slow on the Commodore?
No. There's two issues. If the original floppy had its own processor on the other end, and it was using the GPIO bus, right?
Yes, it was like a separate computer.
Totally separate computer, right? It was happening as it was dual floppy, separate computer, and we talked. That was the whole plan for all of those computers. Where the printer was done that way. I did the printer. I wrote the code for the printer and gave it to Epson, and it wasn't called Epson then, it was still Seiko, but they turned it into Epson. And we just took a calculator style device and put a printer and put a processor. So the GPIO bus was fast enough. What happened was when we wanted to do the VIC-20, we only had a limited space and to do it in, because we're going to build the computer into the keyboard. And so what we did is we designed a new interface bus, right, which was kind of based upon the GPIO, but it was much slower, right, because it was going bits at a time, right? And what you're thinking about is that that bus had a limitation of the speed, right, because of the way it was working. And so I don't think we had to actually slow the floppy down, because I think any computer we ever built was distributed, right? So the floppy always had its own processor, and the printer has its own we never built anything where the computer was actually running the peripheral, except the screen, right? Because I believe in distributed intelligence, and the PC in the 6502 is so small and easy to use. So you design the floppy independently, and then you hook it up, right? And so it could be, if there was some issue, it may have been just because of the special bus. But that special bus is what made Commodore so profitable, because you couldn't buy a peripheral for your C64 that wasn't on that bus, and so therefore Commodore, you had to buy it. So you paid $150 for a floppy on a machine that you paid $100 for, and you paid $150 for a printer that you paid $100 for. And it was so funny. I told everybody that those were the razor blades, right? And nobody would ever complain about the price, and they never did, right? Sell them the razor at a least cheap price, and the razor blades they'll just buy, right? Because they need them, and it worked, right? They sold $1 million plus per month, right? Before the MS-DOS was getting started, right? They were selling $1 million a month, right? It was a very successful program, right? And Trammell was right. It was a very successful program because it was consumer oriented, right? They sold the thing only to people like Kmart and everything else, and it was a totally different distribution channel than the dealer channel, right? The dealer channel was what we moved everybody that was making MS-DOS machines and PC machines. And for a long time, the dealer channel was the one. And the reason was is most of the dealers were guys who were computer guys who just dropped out and started their own dealer companies, and they were because they knew how to put software in to get a guy going, right? That's what they were doing. Most of it, particularly in Europe, the small dealers were actually doing applications for their customer, right? Now there were some volume dealers, and then that's but C64 only went through volume channels, right? Keller is in Germany. Is it Keller? It's the big. What's the name of the big? Used to be the big store.
There was a company called Quelle.
Yeah.
Maybe you mean that one.
Quelle. Yeah. That company was one of the first places to carry the C64.
Ah, okay.
Yeah, and
but the interesting thing is there is a difference regarding the distribution of programs and games for the Commodore machines, and in Europe, for example, in Germany, the floppy disk was quite famous. But in the United Kingdom, still the data set was the primary device to load your programs
is that right?
in. Yeah.
Yeah.
The floppy drive never was so famous in the United Kingdom compared to other countries.
For the C64, you mean?
Yes.
Yeah. There were different marketing groups inside Commodore marketing them, actually, right? And there was a guy by the name of Kit Spencer and a guy by the name of Harold Spire who really made Commodore totally famous in Europe. And he was the one that built the factory in Braunschweig. I don't know if you knew, Commodore was making computers in Braunschweig for a long time.
Yes, exactly.
Yeah.
They had a factory there, and it said made in West Germany. Yeah. On the back.
Yeah. Yeah, and that was Harold Spire who ran. Ultimately, he took all of Europe over when Kit and some of these other guys retired. But anyhow, the point is that Spire was an ex-HP guy, came out of the HP instrument group, and so he really had a good understanding of the. He was with me when we introduced the Peddle in München, and then when we did the other stuff in München, he was always there, and he was such a good guy.
How did you actually manage it with the Japanese market? Because if I'm not mistaken, the Japanese versions have a totally different chart set in it with Japanese charts. Do you know anything about that?
Oh, totally. That's why I tell you need to talk to Yaz Terakura. Okay.
I will invite him for an interview too.
Yeah, you must talk to Terakura because we had Commodore was making calculators in the second city in Japan, Osaka. Commodore actually made calculators in Osaka, and so the Yaz Terakura was out of that factory, and when I went to Japan to meet with Epson and to do things, Terakura was assigned to go with me because he spoke good English, and he taught me about all kinds of important stuff about Japan. And we had a really good Japanese team from Commodore. And the guy who found the screen for us was Mr. Fujiyama and his technician Aoji. And he was the one that found the original tape that we used. And so he had established this great set of relationships. And the guy who followed up on those relationships for him was Yaz Terakura. Okay, so now Terakura is really heavily involved with this stuff. So we brought him over to the States when we were working on the C64 and the VIC-20. And when we left Commodore, he took the VIC-20 over, took it back to Japan, right? Put all the character sets in that you're talking about and everything else. And they actually introduced it in Japan and got it started in Japan first, and then brought it back into the States, right? And so, and then he went back to he went back to Japan because of political reasons, whatever, and they were getting in trouble in the C64. So they brought him in, and he finished the C64 for them. And he and the Japanese finished the C64 also. So Japan was a very important business for us because we were using Japanese engineers and Japanese products, and so that's why the Japanese did their own thing, right? It's because they had the engineering talent to do that, and they did.
There is a famous quote from Jack Tramiel about that saying, "So if the Japanese want to overrun us, we have to become the Japanese."
Yeah, yeah. We started with that, right? But Jack had some good quotes. Don't get me wrong, right? His thing about I want to build a computer for the masses, not the classes, right? That's why he rejected our idea of doing the MS-DOS machines, right? Because he says I'm doing a computer only for the masses, and we kept trying to tell him that the classes were very important market too. And
Yeah, but
right?
interesting thing is that at the end of the 70s, at the beginning of the 80s, Commodore Germany did Commodore PCs actually
Yeah, 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 yeah.
for some
That
years.
that was that was Harold Spire. Okay, and by the way, I don't know if you know the tie, but it actually came through our old company, Victor. He actually got tied into the so
And it was very successful. They were very
yeah,
successful, those machines.
yeah,
So
yeah.
it,
Because Spire actually was when we went back into Commodore because he put a PC clone, right? He was the first guy to convince the rest of Commodore that they were doing Amiga at the time, and he convinced them. He said, "Look, PC clone is what's selling in Germany. I want to do a PC clone," and he built it in Braunschweig, and and
I
they did
have
very
two.
well with it. Huh?
I have two of them as well. Yeah.
Yeah,
Very good
yeah,
machines.
yeah, and so because remember I told you, Spire was a really smart guy, right? And he drove the company a lot, right? His product was always successful. He was very useful for me, right? And he taught me a lot. And I worked with him after actually he took a company over in Lake Constance, and I went down there and helped him with that after he left Commodore. Um, he's a really good guy. Um, I'm sorry to say he died early, right? He was young, but he got some kind of something like the debilitating disease or something, and died. Right? But really good guy, and he was the guy that built Braunschweig. He was the guy that put them into that whole thing. It was all done by him in Germany, right? That was really a German product.
Yeah.
And no, I think I've told you this story, but I will tell it again. I
Sure.
always introduce my product, whatever my new product is, preferably do it at Systems, right? In Munich, because I love to go to Munich, and it's also a very good show to show an idea, right? And the reason I do that is that the Germans are very demanding, but they're very responsive, and they're willing to buy something at a higher price and take a chance. And my point to everybody is if I make a mistake in Germany, I can fix it because nobody reads German press except the Germans, right? Whereas if you make a mistake in English, everybody knows it, right?
Yes, of
And it
course.
really worked, right? It turns out we didn't need it, but that was my reason, right? Because the Germans really are they take a new machine and really beat on it, right? They do a great job because Germans are technically skilled, and there are people that buy them and everything, and they're very demanding. That's the reason Mercedes is a very good car, right? It's because they demand. Well, it's like the Japanese. That's the reason the Japanese cars were so good. It wasn't because they were trying to impress the Americans. They were trying to impress the Japanese, right? The Japanese insisted on having perfect quality, and the Germans are the same way, right? And so it's very helpful to introduce a new product into Germany. And as I said, if you make a mistake, nobody hears about it, except Germans. Um, so anyhow, the point, I think we got way off the track, but the Commodore went to building the 6502. Okay, so let's just go ahead and pick it up, and we'll kind of come back and finish that story up, right? Because I jumped over from the video game all the way because we got talking about Apple and all these other computers and Gates, right? And we never finished about how we actually did the Commodore. I had a charter, right, now with help from Andres Cezanne, to do a computer for the CES show, right? But then after we went to the CES show, we had a charter to turn the thing into a product. And then after this show I was telling you about, Tramiel was totally dedicated to making this a product. So he actually assigned his son, who was a PhD student at Columbia, to work with us for the summer, and I recruited this guy Seiler, who had worked with me, and because I knew he was a computer hobbyist, and the company that he was working for wasn't going to do a computer, so I convinced him to come to the West Coast. And I had at Motorola trained the Motorola engineers and salespeople about the 6800 first time. And in this class was this professor who was in Motorola that summer on a sabbatical, by the name of Roger Camp, who was the guy who was running Iowa State computer courses, right? And he and I had a conversation when I was getting ready to start for the 6502. He found the guys that did the compiler for me for the 6502. So you could go online and write code for the 6502. And so when I was getting ready to do the PET, I called him and I said, listen, I need some help. I need a good programmer. And because Seiler was okay, but he wasn't really a programmer. And I had been a programming manager, but I had too much other things to do. And I didn't want to do the operating system anyhow. So he said, well, I've got this kid who is really good, and he's single, and he's got nothing going on in his life or anything, and he's going to go to work for IBM, and they're just going to lose him, right? So I'm going to convince him to come out and talk to you. So he flew out, and we kidnapped him. We wouldn't let him go home. We sat there and he sat down, and we talked about it, and I put him up in a motel, and I said, you don't need to go home. Let's just get going, right? And so Camp calls me up about 2 weeks later, and he said, what did you do with this kid? And I said, I kidnapped him. And he said, well, IBM called me the other day because they were really worried because he was supposed to show up for work that Monday, and he hadn't shown up, and they couldn't find him, and they thought, maybe somebody killed him or something. I said, no, we just kidnapped him, right? And his name was John Fagans, and he did the operating system for the original PET. He did the operating system for everything through the 664. Really, really solid guy. He did it on his own, right? He was just him at the beginning. We hired later some consultants to help him with some stuff, but he fundamentally wrote. So Seiler was a really good hardware guy, right? And so Seiler started working with me, and we hired one other guy that was local there, and the other guy looked up the idea from a guy by the name of Adam Osborne. Did you ever hear Adam Osborne? He actually made a computer called the Osborne computer, which is one of the first notebook computers. Yeah, I've heard of it. Yeah. At that time, Adam was writing books, right? And he had written a book on how to make a TV work on a computer. So we took his book, and this guy interpreted it, and we built this. But the most important guy was a combination of Seiler and this guy Fujiyama, who was an ex-calculator guy, but who was really understood Japan, right? And so I would tell him, I need a CRT that does this, and he would then get in touch with somebody like Sony, and they would sit down and pick a screen for me, and design a flyback and a yoke for me, and we did that forever. We kept buying new flybacks and yokes and Fujiyama, and the same when I wanted a cassette. He found a cassette. They told me how to make it work. We make it work, made it run really well with the PET. And I had designed the original machine that we showed had a typewriter keyboard, right? Because I felt all computers should have a typewriter keyboard. And Tramiel looked at it, right? And he said, why are we doing that? It's going to cost us money and everything else. And I already have a keyboard tooled for a big calculator in Osaka. And he said, why don't you just take that calculator, which had lots of keys, and make it more useful, right? To the point that people could draw pictures with it and everything else. And I said, well, everybody wants a keyboard that they can type on. He said, let me tell you a story, okay? I started in the calculator business. When I did my first calculators, I was always using the 10-key. I don't know if you ever use a 10-key machine, right? A 10-key calculator. You ever used a 10-key calculator, like the old mechanical ones? Ever seen one? It was a box like this, and it had 10 keys on it, and the people that were doing accounting just got really good at using it. And he said, so I designed a 10-key interface. HP introduced their first computer with like 30 keys and kicked my butt. Okay, he said, since then we've always done calculators with lots and lots of keyboards with lots and lots of functions, because they're basically doing scientific, so they need the sine and a cosine and and all that. And so he said, how do you know that people want to have a type keyboard when I can give them this really nice keyboard with all its functions built into it? And I said, well, I don't. Right? He was right. We didn't know what people really wanted. So again, Fujiyama got the company that made the keyboard, and we put it in, and we made it work, and we introduced it with the big keyboard and with all its functions. And then we quickly discovered that we needed a version with typing, right? Because people, complained about it, and it was really funny because when I showed my son, who'd been with me all the way through this, young son, when I showed him the new machine, he said, "But I'm used to the keyboard." Okay, I like the other keys, and of course today everybody's using little keys to text with, right? So they went from I have to have a keyboard to I'm going to text everything, and it worked, right? But at that time we didn't make it work. And if you notice, the VIC-20 and the C64 were built into the keyboard that was a touch type keyboard, right? And most people still use a computer touch type, right? Or they use the screen that's touch type. But it was just funny because people are using the cell phones to text and all that stuff, and they're typing in little characters much smaller than the ones that we had, right? So anyhow, but the point was is the Japanese provided all that. And then Terracotta and those guys were coordinating that supply out of Japan, right? And they were actually building the first computers there. So it was a very much, at Jack's point about being Japanese, it was very much a Japanese and American joint development, right? That when we did it, and Fagans, and Seiler were the key guys to make all of that happen. Then I hired a couple of guys next year, right? Stole 2 more guys from the university, and those guys came in and did the floppy, right? And then we hired some guys the next year, and there was Bill Russell and those guys that stayed with the C64 and the VIC-20 and made the C64. So every year I was stealing these really bright guys out of the university because my friend was there, and he. And once we got successful, of course, then it was easier sale to these guys. But if it hadn't been for him, they wouldn't have come and seen me, right? And he always picked them. He said, "You have a particular model. I'm not going to ship you a guy that will do well at IBM, right? We'll ship you guys that want to be different." And they really, I had this team which I kept together through 15 years, right? And we've actually. For my new company, we're bringing some of them back in right now. This is a long time later, right? Because they were guys who just got used to working close together and did really good work and very independent work. We didn't have a lot of help from other people. I think there was, at that time there wasn't a lot of functions around and people around, right? We worked a little bit. Fagans worked a little bit with Microsoft, but they were off doing their own thing, and there was nobody else, right? We had to kind of make stuff up as we went along. But these guys were really well educated about how computers work and the computer science, because and they knew about microprocessors because this professor was teaching them using my microprocessor. So the 6502 was being used by a lot of, because we had the Kim 1, so people could sit down in the lab and create their own little programs with the Kim 1. So for a long time, that was the way college students learned about microprocessors with 6502 and Kim 1. And then after we got into the 8088 stuff, then everybody either went Apple, right, or they went to Intel machines.
But this concept of one computer per household, or 2 computers, or more computers.
Oh, well,
where did you get this idea from?
Because of the fact that I worked on BASIC and I knew what people wanted. Right, I had run a major group in Ohio I had all these engineers writing BASIC, right? But more importantly, when we did the 6502 and we took around the 6502 in the CAM, all these programmers and accountants came to us and said, we want a machine, right, that is turnkey. We don't want anything else. We want a machine that we just plug into the wall and use. And that was the idea, was that, so it didn't come in the middle of the night. It came in response to the marketing, right? That people were telling us what they wanted, and it's what I wanted to do also, right? We had actually built CRTs that looked like that and things like that before. So it was clearly Radio Shack wanted it. They had actually written a spec. All these customers said they wanted it. It was really easy that we wanted to have an integrated machine. And in fact, Apple, if you recall, didn't do that, right? And we did it, and it really took off successful. And then Radio Shack did the same thing, and both of us were much more successful in the Apple, right? Except Apple got to be really lucky. The guys at VisiCalc put VisiCalc on an Apple first. VisiCalc, I'm going to compliment those guys one more time. VisiCalc was the first program I ever saw that was exclusively for personal computers, right? I worked in big computer companies, and we had online programming, and we had electronic mail and word processing and all that stuff. But nobody had ever made a thing like a spreadsheet, right? They created it. These guys in hardware in their back room created this thing called a spreadsheet. And of course, now nobody knows how to run a business without them, right?
Yeah, everybody is using Excel nowadays.
Yeah. Well, what happened was, so VisiCalc was on the Apple, and people started taking the Apple to work because they could do VisiCalc on it. And so it really took off for them, right, as a result of that, and actually saved them, right? And the same thing happened, I don't know if you know the story about the Mac. The Mac came out, but it was fighting against a bunch of machines, PAC machines that were a little less expensive and were good enough. Although they had Windows and the machines didn't. But Adobe put the software and all the printers in the world and all of the artists in the world started using the Mac because they could do typesetting with it and do type with it and then do graphics and it today, if you look at the Apple users, almost everybody who's an artist or design site always uses Apple only. They won't even think about anything else, right? Whereas the computer guys and business guys and so forth usually use PCs. But it was a specially created market, and Adobe was the first thing. And, because Adobe was solving a problem nobody else was solving, it really took off, right? And helped save the Mac. Okay, but that's a deviation. Okay, so I just finished. So we had this team, Japanese, English guys stealing from Pennsylvania and stealing from Florida, and this small team put together this whole business, right? And the guy who was writing the initial software, when we shipped the software, we shipped the machine, we wanted to show people how easy it was to use the graphics. So we shipped them a little program that they could write that would make this thing called Lunar Lander. I don't know if you ever used it. Did you ever use it when you were?
Yes, I know.
That program was written by Tramel's son, who was helping us get everything done. He was checking the machine and everything, and he wrote that program so we could include it for everybody. And it, if you look at it, it showed you enough about the graphics that kids would then start doing their own stuff with. We actually made it to the point that people could write their own code. We're writing their own visual stuff, and it was a lot of fun, right? Was right long term. You needed the good graphics capability, better than our character graphics. But for getting people started, the combination of basic and the character graphics let everybody get comfortable, right? And really and truly, in order to make the graphics work, you needed all of these tools, that people made. Here's how to draw a circle. You could buy. I keep forgetting the name of the tools, but they started shipping them, right? With the machines, right? So that you could put together something. It was subroutines, but they had a name, a visual name, and I can't remember the name. It's used to be really popular, but it's gone away. Where you would take And if I want to circle here, I would call this subroutine and tell it what the percent parameter was and where I wanted to circle, and then it would draw the circle for you, right? And almost all the graphics became driven by these little subroutines that people were providing. And I don't remember the name, but it was actually a programming term, and they taught programmers how to use them and how to write them and everything for a long time. And now it doesn't matter, right? The languages have moved up enough, and Windows is sophisticated enough and everything. It's less important, right? And you can buy all these really fancy CAD programs.
Yes, it's interesting. At the same time we will release this video, we also will release a video with Alexei Pechetnov, who was the creator of Tetris. And he also started Tetris with character set for graphics.
Yeah.
So that's probably the most known game starting out without computer graphics. That was actually Tetris from Russia. So.
Because he didn't have the fancy drawing capability,
exactly.
right?
Exactly.
You know, the character set was something you could do pretty easily, and it fits nicely in BASIC, right? You know, the basic statements to do that are really simple. And yeah, did he write it in BASIC or did he write it in some machine language?
No, I think he wrote it in Pascal, if I'm not mistaken.
Possibly. Yeah. Pascal was very popular right about that time. I'd forgotten Pascal, right? I mean, you know, Fortran, COBOL, Pascal, all of them have come and gone, right? You know, they just don't exist. I mean, maybe Pascal is still around, but I don't think so. I think, yeah, because Pascal was very popular because in Finland and all of Scandinavia, so I could see how it'd be popular in Russia too, right? Because there's a lot of technological.
But he didn't know machine language. He didn't know assembler, so he had to get
Yeah.
a student to do it for
Yeah.
the PC and so on. Anyway, so at least that idea of having character graphics was maybe also a reason for making the machine successful for games.
Absolutely. No. It was more importantly, the character graphics was an important way to make it personal, right? You know, to move it from being just a keyboard typing on, right, to having something that was more personal. That was why it was important, and that's the reason we gave them the game and everything. And most everybody used that feature, right, because it made the computer more. And remember, this is at a time when video games were becoming very popular, right? Nintendo and all those guys were coming out very hard. So it was a bridge, right? And then, of course, the C64 was a great game machine, and it really, you know, I don't know if you know the advertisement was the C64, but the advertisement is your child needs to be computer literate, right? And this is the cheapest computer you can buy that will make them computer literate. And the kids were all saying to their parents, I want the computer, but they didn't want the computer literate. They wanted the games, right? But it turns out that every one of them, I've met all kinds of kids of it. They all learned BASIC, right? They all learned about the computer. So everybody who owned a C64 became computer literate, which is what I wanted, right? You know, I wanted these guys to be comfortable. So they went on to buy computers for the rest of their lives, right? And everybody said, well, why wasn't there success in the C64? It didn't matter because the MS-DOS machines were coming on and they were doing more, right? Real peripherals, you know, real better software and everything. So, okay, it was a legitimate transition. But they started out being computer literate before they moved there. And nowadays, there's a whole bunch of people that just buy computers and plug them in and run Excel and things like that who are not truly computer literate, right? But
true, yeah. Nowadays they have your mouse and your interface and your windows.
Yeah, but I think what's happened is that they pick up a need for the computer, though, right? I used to tell everybody that computing is a need like sex. You can do without it for a while, but you need to come back to it. It was true, right? People, yeah, if you take a computer away from people, ask them, right? That's why the pet was no problem. And people will always come back to needing a computer, right? I mean, what would happen to you if I took all your computers away, right? You would not be a very happy person, right?
What was interesting, what was interesting to me is actually how did you start your career? I think that's something that's very little known about you because it's not mentioned in the books or on the interviews I've read so far. about Commodore or yourself, how did you start your thing?
Okay,
Was it a childhood dream or?
no. Let me tell you something that was really important because I try to tell the story. I'm surprised it hasn't made it out more. I was I came out of school when there was no real heavy television, right? I came out of school in 1948, 55, 54, 55. And so television today, you wouldn't even think about a life without television, but television was newer, right? My family didn't get a television until 57, right? You know, I mean, it was something new. And so what was popular during that time was disc jockeys, right? You know, you went on the radio, and this is when music started taking off. It was more than just country music. It was all kinds of popular music was coming along, and the people that were driving that were guys called disc jockeys. They would get on the air, and you'd have a 2-hour show, and you would tell people about the new stuff, and you would give stories about the guys who were making music, and sometimes actors and so forth, um, and so those were very popular people, right? And I liked speaking in an audience, right? So I was lucky enough that my there was a speech club that had access to using disc jockey, and my neighbor 3 houses away was the owner of one of the radio stations, right? So he gave me a chance to go on, and I got to do this all the time I was in high school. I was being a disc jockey and having a good time doing it. And so I thought that was going to be my career, right? I was going to be a disc jockey. And so in order to get further up the food chain, you had to go to these fancy schools in Boston, right? So I put together a presentation and went to Boston, and I sat in a room with really good artistic people. And I came away saying, oh shit, right? I'm not that good. I really don't know how to do that. So I went home and I talked to the radio station manager and also my speech teacher. They said, we're glad you figured it out finally. We didn't want to tell you. And the guy says, listen, I'll give you a job, but you're never going to get out of my station, right? You're just not good enough to be going up the chain. But we've talked to your science professors at school, and you're really smart about electronics, right? Remember, electronics is vacuum tubes and stuff like this. There's no transistors haven't happened yet. And he said, I think you should go to school and study the new electrical stuff. And if you want to get into radio or television, come in from the technical side. And he says, I think television is going to be the hot place. So what you want to do is you want to get good enough so you can come in from the technical side of television. So I applied very late to engineering school, but luckily I was in a state where they had to take everybody that applied. So I got into the school and I started, and I actually enjoyed it a lot and was getting good grades, high level grades. But I still had kind of given up. I'd given up the disc jockey thing, and I wasn't sure I wanted to do television either. So I just kept taking courses that made me smarter, but didn't specialize, right? So my junior year, I had a hole. Because I was doing so good in school, I kept upping my class limits and kind of showing off, and there was a hole in my schedule. And there was this little class called communications theory. It was being taught by this guy for 1 hour. And I went to this class, and the guy who was teaching it, do you know Claude Shannon? Have you ever heard of Claude Shannon? Oh, you need to read about Claude Shannon. He is the guy that invented the telephone system. He's the guy that invented the word bit. He's the guy that invented byte, okay? Because he was describing how a digital computer phone system should work. He was the guy that took the phone system from analog, and he's the father of information theory. But you see, the problem is that we're so far away from him now. You don't study it in school anymore, right? You just ignore him. But he was absolutely the father, and he was at MIT, and the guy who was teaching this class had worked for Shannon directly, and they were developing the phone system at that point. The phone system at that point was still operators plugging stuff, and they just started going digital, right? And the only way they could go digital, switching and so forth, was because of the work that Shannon did. And so this guy was trained by Shannon. He was actually working for Shannon, and he had a nervous breakdown. And so because he wanted to get away from it all. The doctors told him he needed to get away from it all. He just couldn't handle the stress of the high-tech stuff. He came to my little cow town university, which is up in the woods, and they were so happy to get a guy of his talent. They gave him this really relaxed schedule, right? So he only taught like 6 hours a week or something like that. And he was getting paid top dollar. But anyhow, so we walk into this class, and this guy says, I'm going to teach you about communications, right? Because that's why I've been trained. But we're going to start you off with the ultimate communication tools. Do you know what they are? And we said, no, we're not sure. He says, it's your ear and your eye. So without hearing or without seeing, you can't communicate, right? And so he made us study the ear and the eye first. So the point, I can tell you everything about your ear. I can tell you everything about your eyes, right? Because he made us learn those. And then he started some games with us. And one of the games was, he walked into class and said, today we're going to play a game. Give me a letter. They call out a letter, strong letter. He would have a phrase ready, right? And they would come out and they would get an A or something, relatively easy. And then we'd get into the words, and it would take a long time. So he just wrote down the number of times we made a mistake, right? And then he showed that if you were here, the next letter you got perfectly, like one time, right? And he says, that's the basis behind the phone system, right? The language is redundant. So what we do is we take all of the easy ones out, right? We can guess them. And so we only transmit the hard ones. And then the rest of it, the computer just puts back in the rest of the language. And he went to improve that. And so then partway through the class, he swaps to French, which of course, enough of us knew French that we were able to catch it partway through. But the guesses were way off until we figured out it was French, and then they got to be the same thing. And he said, look, I'm just to prove to you that if you know the language, it's highly redundant, right? Think about that. You don't think about it every day, but it was really an important step. And then he said, now I'm going to teach you about computers. And he taught us about binary arithmetic. Do you know how to do binary arithmetic?
Yes, I have to learn it.
Yeah, okay. So he taught us about binary arithmetic, Boolean algebra, right? And then he took us into how computers work, right? Somewhere in the middle of that class, I said, that's it. I now, after 3 years in college, know what I want to do with my life. I am going to work in digital computers, period, right?
Okay.
The transistor was just invented, right? We were talking about still computers that were being built, but it didn't matter, right? The math, the precision, and the way you could do logic and all that stuff was so attractive to me that I said, that's what I'm going to do. And I just hung in there. And when I interviewed the next year for jobs, I only interviewed with people that would send me to the West Coast, because the Marine Corps sent me to the West Coast, and I fell in love with California. And I was a part-time Marine during this time. And and so I went to school, right? I mean, I went to the West Coast, and I said, I'm only going to interview with you if you have a West Coast operation. And if you'll commit to me, then I'll go to the West Coast. And so the company that hired me was General Electric Company. But so I knew, and when I left my campus in 1959, there was not one computer on the campus, anywhere. Not one. Not for the administration, not for anybody. There was no computers on our campus. And we're a big campus, right? And we were teaching PhD courses and everything else. 3/4 of the professors were still teaching vacuum tubes, right? A lot of the new guys didn't even understand how to make a transistor. I designed a transistor thing as part of a physics class, a lab, and I did it and get it all right, but couldn't make it work. And I went to the senior professors in that department. They couldn't make it work. When I first got to Phoenix, I was showing this sketch to this engineer, and he says, well, let me explain to you. The way transistors work, you got to have a pull-up here, right? You have to put, if you know about pull-ups, but you have to, you get the signal, and the transistor switches and gives you the low signal. But if you want the output signal to be high, you have to put this pull-up resistor on. Now that's trivial, but nobody knew how to do that, right? This is really and truly was that time. So I came out of school, no computer education at all other than this class. And luckily did a couple things. I worked on nose cones and jet and the Gatling gun and all that stuff for GE for 9 months while I had a baby, and I had to stay home close to home until my wife had the baby, and then we moved to the West Coast, and I had some really smart guys teach me about computers, and I was working in a design group in Phoenix, and then I went to Northern California, which our computer lab was there, and we worked on all kinds of things. But I got to meet a couple of very interesting people there. But we were trying to use cryogenics. Did you ever hear of cryogenics?
No, not for now.
Cryogenics is the low temperature. If you take anything with resistance in it down to a certain low temperature, it starts to become superconducting.
Oh yes, no, I see.
Yeah, and so we were trying to make a cryogenic computer that was fast. And, we were doing a bunch of stuff like that. I mean, it was really a lab, right? And out of that lab came Bill Davidow, who created the 8088, right? And the other guy that came out of that lab that was really important was the guy who went to MIT and created Project Mac. And I think I've told you about Project Mac, but let me take a minute because this will give you some more of my background. Project Mac project was to give every programmer his own computer. You went online, it was your own computer, and it had all of the data you wanted and all of the programming space you wanted and all the computer time you wanted. And Weizenbaum had us design in GE, when I was working GE in Phoenix, they had us design this really powerful set of computers that were running back to back. And so the image when you were out there was that you had your own computer, right? And the people, right, who did that, Joe was a guy by the name of Joe Weizenbaum who had worked in the computer lab, right? And he was the guy that drove this. And today, if you talk to a graduate of MIT, they have used Project Mac, right? Because it was a language called GCOS, and it was the language that Western Electric was using, Bell Labs was using, and they were tied into this computer at MIT, and they got bored with the long time it took to communicate, so they moved it into a local computer at MIT and called it Unix. And that's where Unix came from. It was actually a derivative of this thing that Weizenbaum did. So I knew about Weizenbaum. And back to the making a computer for people, right? Think about it for a minute. Weizenbaum was giving them a terminal, was giving them a computer. When I gave them a pet, I gave them their own computer right then, right? And he had proved that it worked, right? He'd proved that people wrote better code and everything else if you gave them this distributed. So I had that background, right? I had this training. I went and we designed the computers, and I was actually doing automation for designing computers. We did all of the layouts, and then we did the first PC board layouts and all that stuff. I was in the design automation group, so I got to work on all the projects, and that's when I learned about BASIC, and I learned about the work that was done with MIT, and I worked about all this stuff. So I had gone back to run this computer lab, this big computer group, which was one of the biggest computer user groups in the company, and that's why I was using the GE engine, these computers to design time-sharing computers, to design jet engines with. And I wanted to come back to the West Coast because I thought at that point I wanted to start a time-sharing company because everybody liked BASIC and they wanted to be online. And I thought I would come back out to the West Coast and start a time-sharing company. About the time I got to the West Coast, people figured out time-sharing was too expensive and quit buying it from GE. But so I was in a department whose job it was to do the next generation things. And the group I joined had done an online cash register system, right? Where the cash register was just a screen and a keyboard. And every decision, all the logic and everything else went over network to a computer so if you typed the key, that key printing on the screen went to the central computer, okay? And then when you wanted to, if you did a calculation, it was always done in the central computer, right? And I had a real breakthrough. The thing you were talking about breakthroughs one day, I sat down, I said to myself, I know what's going on in the semiconductor business because I had actually had an offer to join what became Intel. And I said, people are making really complicated, sophisticated stuff in 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 chips, right? And I said, why are we building devices that have any remote computing capability at all? And so I defined a thing called distributed intelligence, right? And I tried to sell the idea with inside of GE. And this radar thing, which was what it was called, failed because it was hooked up to a retail store in pennies, and they had a whole store set up to it, and they put it online. In the U.S., the day after Thanksgiving is the biggest shopping day of the year, right? And they decided, oh, we've run some test cases. Let's see. So they hooked this store up, hooked it up so it would that all of these things, in order to take any money or anything else, you had to go through this online system, and the online system crashed. So this entire store could not sell anything in the busiest day of the year. So people started listening to me a little bit about the distributed intelligence, and we actually met with people like Exxon about putting them into gas stations, and we met with people about putting them in cash registers and credit verification. We met with the people that started Visa. You know, at that time, credit cards weren't so popular, but they started happening. We talked to those guys about they needed a terminal, you know, to be able to make the Visa thing work. So we were getting ready to do that, and GE decided to sell the company and sold it. Right? So all of a sudden, I had no place to do this, so we went off and started our own company. And for 2 years, we made this computer that was a good cash register online. And then we needed to have the chips to make it work. And so I told you the story. I went to work for Motorola to make the chips to make it work. So I knew what I was doing. I knew exactly what I wanted for the 6502. I wanted something that would replace what I'd done in Logic. And but it was designed so you could put a little computer in the cash register, another computer in the printer, another computer into the credit verification. In the gas pump, you needed two computers, right? One to run the gas pump, another one to communicate. And I had all this stuff all designed out. So when I was designing the 6800 and the peripherals, I knew exactly what I was doing, right? I knew what I wanted to do. So that carried over into the PET very easily, right? The PET was a personal computer cash register, right? I mean, so that revelation wasn't then. It was when I started, when I got this idea about distributed intelligence. And I still totally believe in it. As a matter of fact, our new chip we just did has 11 microprocessors in it. And everybody says, why do you have 11 microprocessors? And I said, because each one has a task to do. Remember the concept of distributed intelligence. You let this one do a task, that one do a task. And if you try to share the task, the code gets very complicated. Whereas if you let the computer do one thing, interrupt driven, you can make it do two. You know, like you can pay attention to the input output, and you can drive the flash. But you don't want to do anything else. You don't want to talk to the other one or anything else. Just let that computer do its job, and then you put another one in to do the next job, and another one to do the next job, and it really works. It's worked forever, right? And it still works. But most people have gotten away from it. They're trying to use these big, fat, 32-bit, 64-bit computers with complicated languages. So the world has actually deviated from that. And guys building controllers still do it, right? But the bigger computer guys have wandered off into space, and that's why your Windows runs so slow, and that's all of this other stuff. Is because they've lost track of this idea about break it down into small tasks and let the task get done.
So your story goes like this: you started from your from your computer or communication classes over to General Electric, then to Motorola, and then you started as
Voice technology. Right.
And then that company was bought from Commodore.
But not to buy the personal computer. Suzanne and I convinced Jack to do that in addition to the computer. He didn't buy MS technology for that reason. He let us do it
because of the calculator.
And the ability to make their own calculators, right? Yeah, no. But Suzanne, vertical integration. But Suzanne was totally knew why we were doing it, right? I mean, he told Jack at that point. Jack trusted Suzanne, Suzanne actually got thrown out of Commodore for the same reason everybody else got thrown out of Commodore. He got crossways with Jack on something, and he went over to Apple, and he gave him a lot of money, funding, and he bought the European rights. So for the longest time, Apple in Europe was only sold by him, and he became the biggest shareholder in Apple because before they were going to go public, the investment bankers said you can't have a market like Europe not be yours, right? So they
Oh, I
went to
didn't know. I
Suzanne.
didn't know about Apple. I thought it was Atari actually.
No, 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 Apple. Suzanne had Apple, right? He had all the distribution rights for Europe, and they actually had to buy them from him, and they made him he became the biggest shareholder in Apple for a while.
So why did you actually leave Commodore?
Jack Tramiel threw everybody out at some time or other. He threw out Tom Mitchell, he threw out me, he threw out everybody. Tramiel used to just go through people.
Okay.
He'd get angry for something or other, and even though Andre made great money for him and everything else, just throw him away.
And that is what was called Jack Attack, when he got an angry attack.
No, that was a different. No, Jack Attack was Jack trying to fix you, right? If Jack was going to throw you out, there was no Jack Attack. He would just call you in and hand you your termination paycheck and say, "I want you out of the building in an hour," right?
Okay.
I mean, he was really blunt about it, right? No. Jack Attack was when Jack thought you could be fixed, right?
Okay.
So he would jump all over you, right? And that was when. Yeah, so I didn't have that many Jack Attacks. Jack and I had arguments, but I never had that many Jack Attacks because I was usually ahead of him, right? Our arguments were about how far ahead I was, right? And then we, of course, had a fundamental argument about should we go into DMS-DOS kind of machines. And we actually offered to set up a separate company inside of Commodore to do that because the CFO, my buddy who helped finance Victor and I, he was a distributor. He was running all the distributors in Europe. We knew that there was a new market. You know, this market was coming, and our local guys in Europe knew it because we've been making these high-end computers, Commodore computers called CBM, and we knew that we needed a new generation of machines. And so what we were saying to Jack, finish the C64, do VIC-20, do all that stuff. It's a business. It's a business you don't need our help or much of our help. Let us go do this thing which requires a whole new operating system, a whole new structure and everything else. And we'll make you the biggest guy in office computers too. And he basically turned us down and threw us out.
Okay. So, actually, what I wanted to ask is, you made once a statement that you were angry, of course, that he threw you out, but you also said that he was the person who gave you the possibility to make all you wanted with the pad.
I want to tell you something. The only thing I was angry about is after we left Commodore, right? We left Commodore. We left them the VIC-20. We left them everything. You know, we didn't leave them dirty at all. We left them clean.
Okay.
We started this other company, right? And he decided he wanted to suppress that company, so he sued us.
That was serious or something?
Yeah, serious. And he sued us. So we had to spend a lot of money defending ourselves. But more importantly, at the end of that, there was a lawsuit where he dismissed the company, but he went and tried to take my shares back that they had given me, even though I had no more shares than anybody else. I actually had the same number of shares as everybody else who had made their shares and sold them and everything else. And he had promised me originally when I did the original PET that he would pay me $1 a machine for the rest of my life and all kinds of things. And he went into court and lied and convinced some judge who shouldn't have been the judge, right? And we just did that so badly that they could take all my stock back. So I went from being worth a multimillionaire to nothing in a day. And I was not happy about that. Okay, right. That was what I was angry about, is that he lied to do that. And the fact the court let him get away with it. And I had some really serious problems in my family as a result of all that. And luckily, we had started Victor in the meantime, and Victor was getting ready to go public, and so I recovered my fortune relatively quickly. But, you know, I had made this happen, right? I had made the whole company happen. He didn't have anything to do with it. We made it happen. And he just lied and told him that I shouldn't get anything. And I was angry about that. But I still went to him and said, you still gave me a chance to do something nobody else gave me a chance to do, and we got to change the world, and thank you for that. And it was true. He did back us early, right?
So you cleared your stuff with him before he died a few
Yeah, yeah.
years
Well,
ago.
actually, he was visiting JTS, which is a company he had acquired, or they'd acquired Qatar, whatever. He was there, and so I took the chance to do that. And, I mean, it was a pleasant conversation, but nothing more than that. My wife was so disappointed because we had been very close to them. We went to Vegas with him. We did all kinds of stuff, and for him to just say we did nothing was an insult to her. She sold the first computers, right? He had this idea about we should take the money because we could use the money to build the factory, and she was taking the checks in. I mean, she actually was the one that did that for him, and for him to say we didn't do anything was just not very acceptable.
So you were not only an employee for him, you were also some kind of a close friend. Or
Yeah, it's pretty close. Yeah, for a long time. Yeah, and his son Leonard we stayed friends with for a long time, right? Uh, yeah. So no, it was very disappointing, right? And it was more disappointing to my partner, who Jack had treated like a son forever, right? And when he went after us, my friend was really angry.
and from one day to another, you were like fired, nothing.
Well, no, not so much fired. Like in Chris's case, Chris would get doing something. Jack would tell him, you know, he used to be CFO, but now we got a new CFO, and now I'm going to make you a distribution manager, and then I'm going to give you Europe, and then he took it away from him several times. And so Chris would always get a new assignment, right? But his new assignment meant that he had to fly all over South America and every place else and manage those distributors and things like that. So he went from being the CFO, right, to being this guy who was having to fly around. And that was the kind of thing. He said, this guy, John Carlton, he made John Carlton spend a year in Asia without coming home. But when he came home, he was back in the family, right? I mean, Jack treated some of these people like that. And I think he treated us badly because he was angry about some stuff. But I think he would have probably thought that he would be able to reconcile with us, because before he'd always been able to put things back together with his people. But we just said, hey, that's it. Bye. We're going to go do our own thing, right? And you just gave us, and we won the suit, right? We won. They actually dismissed the suit because we hadn't stolen anything from them. If you think about it, the PAT was going one place, the CC4 was going one place, and the MS-DOS machines were coming from a totally different place. So we had to recreate that, and we knew that. We hadn't picked the 8088 before we left school, Commodore or anything. So all of that was brand new, right? There was no carryover. The people were the same, but he treated them badly, so they all went with me.
So you think the reason Commodore actually went bankrupt is because they didn't jump to the PC market, to the MS
No,
market?
couple things. Trammell, they never had enough money, right? Irving never let Jack accumulate enough money. So he was finally accumulating enough money because the C64 was doing so well. But he wanted to do his own next generation machine. Now, you probably heard about this, a C128 or something rather that he was going to introduce.
Yes, yes.
And
I had Dave Haney in the interview last year.
yeah, and so what Irving discovered when Irving fired him is that Jack had taken all the cash they had and bought all the inventory for this next machine. So even though they were making a bunch of money, they suddenly were out of money again because the new machine had to go and it didn't, right? And that Trammell had risked everything. He blamed Gould for never giving him enough money, but Gould basically said, that's it, goodbye, right? And because he had effectively almost bankrupted him again, right? And ultimately, the Amiga wasn't enough to pull him out of it, right? It was okay, but it never was enough. And Spire did the stuff in Europe, and that was okay too. But we came in and hurt Spire a lot when we came in with Tandem, because we were able to undercut him in a variety of ways. So he took over his position in Europe also.
Which was probably a mistake at this
what?
time. Which was probably a mistake to take over his place.
No. We built this company Tandem up to be a very big competitor. We did the 286, and then the 386, and then the data pack. We did those products at Tandon, and Tandon was the number 2 player. It took over, and we didn't take him over. We just beat him out of the market, right? We just pushed him away, right? Because we had a superior product and a superior price, because we were more vertically integrated. We were making our own disk drives, and we were very aggressive with what we did, and we had some good advertising, a good team, right? And so we were able to take the next generation machines, the 286, 386, 386XS, those things. We were able to do much better with them than Commodore could, because Spire didn't really have that big an engineering team, and we had a good team, and so we had aggressive, we did aggressive marketing, and we did some smart stuff, and the combination of the two, we just wiped him out. And the Amiga never went anywhere. They never really made any real money on Amiga. It was there, and a lot of people liked it and all that, but it never made any money on it. So once we'd squeezed him on the other end, they had no place to go.
So let's talk a bit about what do you do recently, and what did you do ever since?
Well, okay. We didn't really talk about the fact that we did the Victor. We won Computer of the Year against the IBM PC, because we started with a design for a new computer. It was an integrated. Again, we built the CRT in, even though later on everybody got away from that. But we built the CRT in. We built speech in, which nobody had done at that point, right? We built sound in, which nobody had done at that point. We put networking in very early. But the most important thing we did with our MS-DOS machine was, as soon as we got it accepted, we put the hard disk in it. And the hard disk is what changed the computer industry, right? We knew that was coming. I had worked on hard disk at GE in 1962. I actually filed a patent on zone recording in 1962. I was the first customer inside of GE to use hard disks with our own computers we were using for. So I had a really good understanding of why you wanted a hard disk, right? And I would actually, when I was at Apple for a while, the Windows concept, the screen and all of that stuff was developed in the research group from Xerox in a place called Park, which is up in Palo Alto.
Yeah.
And out of that is where Ethernet came. And again, the people had to leave the company and do Ethernet, right? Park couldn't ever seem to get a product out of there and into the marketplace, right? They would have these great ideas like the mouse and all that screen and everything. So I was working at Apple for a short time, trying to define the next generation computer for Apple. And Steve went to Park to see what Xerox had, right? And the people at Xerox said, why don't you do something with it, because we can't get Xerox to do something. They put it in one of their machines, but they're not putting it in the computer, right? They put it into the word processing system. And so he came back from that meeting, and he and I had lunch that day, and he said, I've decided that I'm going to take it and I'm going to make it work, right? Because it's the right interface for human beings. And it was more primitive, the Apple original stuff was more primitive than ultimately Apple became and Windows became, but it was in that day that he had this conversation with those guys, and he said, I'm going to take it and do it. And effectively got Xerox permission to do that, and did. So his machine, which he was designing at that point, which was called Elisa, was a $10,000 mini computer, but it had all those features in it, right? And then the guy who wrote the great manual, I'll remember in a second, for Apple, and really helped them sell the original Apple. He was a guy that introduced Steve to the people at Park, and he decided that Steve was building a $10,000 computer, and it was the wrong thing. So he got people inside the company to work on the Mac. And he had the Mac more or less done when Steve discovered that the Lisa was not going to sell. And Steve was later quoted saying that, well, I told him when I left that you can't sell a $10,000 computer. That's not what people think of Apple for. And Steve actually quoted that later on when the Lisa failed and he came out with the Mac. He said, we're never going to do a high-end machine again. And so Jeff Raskin's the name of the guy. And so Raskin had also ported the software, so the Mac was definitely superior to anything that MS-DOS was doing during that time, just totally superior. And it took a lot of pressure from those of us that were selling MS-DOS on Microsoft to get them to do Windows. And, but ultimately they did, and of course, and then, really hurt Apple a lot when they came out with Windows because but we put the hard disk on before Apple had, right? And that was a major breakthrough. That we did that in 1982, 82, 83, and I'm going to tell this story again because you have to listen to it. The hard disk was being sold against floppy disks, right? And we had made a floppy disk that had a megabyte of data on it, right? So we had two floppy disks with 2 megabytes of data. IBM's was only like 300 KB or something like that. And it was using some of the techniques I developed way back in GE before we patented them. And so when I came out with the hard disk machine, Juggy Tannen and I said we're going to launch it at this show. And I think we had 10 megabytes, but it might even have been just 5 megabytes. And so we introduced this machine, and we took 5 of them and put them off in a corner somewhere. And I went to the press and announced, here's what we're doing, and this is really important. And the press came back and said, why is this important, right? You already got 2 megabytes. Now, what do we need more than 2 megabytes? Which, of course, is a funny story today, but, at that time, you got to remember we were coming from PETs, which had nothing, and the market hadn't begun to eat memory like it does now. And I said, don't worry about that. I said, what you do is you go back over in the corner, and I'll give you 15 minutes on the computer, and then come back and ask me the question again. And of course, the machine's interaction is so much faster than with a hard drive, and particularly then when we'd optimize, because we wrote the software. Microsoft wasn't capable of writing it in time. So we wrote the software, so it was really fast, right? And so now all of a sudden, the things that he used to have to wait for the floppy to do are like that, right? And they all come back and said, I'm never going to use a floppy machine again. I'm going to only have a machine with hard disk. And of course, it took off and became the standard at that point, okay? But my point was that was a really important move for us, and we knew that we were doing it. So we made that move. We introduced it to the industry. IBM made a decision to redesign the PC totally. They brought another guy in. They redesigned the PC. Made a terrible decision on who they did the hard disk with, and so they were behind on their hard disk program for almost 6 months. But ultimately, then Compaq came along and did the same thing. And people wouldn't think about doing a machine today without a hard disk, right? But what's happened is that Microsoft got that free, right? Because I did the software for them, and we did the marketing. And then, so when we're getting ready to put Windows on, IBM was pushing Gates to do another version of a special operating system for them. And he'd been so successful with his original MS-DOS thing, he was seriously thinking about following IBM. And we had to put a lot of pressure on. We had Xerox, a couple of people, had put a lot of pressure on him to keep Windows going. And the Windows guy actually came to me and went up to one time and said, please tell Bill not to cancel us. And so we put pressure on him. And of course, once it came out, combined with the hard disk, combined with all the other stuff, he just ate the market up, right? I mean, the market went crazy, if you think about it. From the time he put Windows on, for the next 5 years, people only bought PCs, right? Apple almost went out of business, right? I mean, and the problem is that they have neglected the hard disk part of the operating system since then, right? The hard disk is slower now. You use your PC, right?
Yeah,
it's slow, right? It's slow compared to a Mac. If you're using a Mac, right? It's slow. It has no recovery. Half the time you lose some of the files, right? If you get power down, you lose all the files. You get all kinds of messed up. Whereas the Mac has this thing called snapshot, where they beat the disk hard and they keep putting all this stuff, but they recover instantly and you never lose data. And Microsoft didn't do that, right? So Microsoft has let the speed of the interface fall way off, and because of that, Apple has really stolen, anybody that wants to have a machine they like and responsive and everything else, because, they both have Windows, right? That you can argue that. And so, they try to do Windows 8, which is a tablet, which is just ugly, right? Everything they did there, they screwed up their existing base, and they didn't really get the tablet thing right either. So, and whereas if you look at Apple, they really separated the two, right? Their tablet wasn't another Mac, right?
Yeah,
The tablet was a tablet.
thing.
It was a tablet, right? It was just specifically designed to be a tablet, right? And there's correlation, right? But it's not. They didn't care, Whereas they tried to mix them all up. So what's happened is that the market for PCs has continually declined, right? Even though guys like Lenovo and some of these guys are opening China up with PCs, right, more so than Apple. And so a lot of the growth is coming in third world countries and people who haven't bought machines before. But most 1.5 billion people own a PC today, and none of them are upgrading because all the new stuff is worse, right? So they're putting up with slow PC and all of this other stuff. So I'm going to answer your question now. I've solved that problem. We have a patent that lets us make all the interaction with the disk, solid state disk, all the interaction is at full speed. And because SATA is very fast, every operation that you do appears to be instantaneous, including if you lose the system, it comes back almost instantaneously to where you were.
Well, that is what you work on at the moment.
That's what we're working on right now. We done it. In order to do that, we needed a USB flash interface, and I have a patent on how to buy. I spent 10 years buying memory that nobody else could use and making it work and making DIMMs. We built a nice big company out of that. And then what we've done is we have a patent that lets us use the flash that nobody else can use and use it as full value. So our products are very low cost and have all of this new features built in. And we hope to do very well with that product.
Good luck for that. So now we have covered the 60s, 70s, 80s, and now
you didn't cover the 80s in Commodore. After Victor got into trouble because we didn't do a PC clone, right? During that time, we needed to have a PC clone. When we got ready to do PC clone, we had some internal management problems, and the people that were backing us threw us all out and bankrupted the company. And so we came back into the market with Tandem, right? And we actually built Tandem up to being a very strong, and we did it based around the 286 and our own hard disks. And then we did this product called the Data Pack, where we move the operating system and everything to the disk, and you move the disk from home to market, right? And that's what you do with a USB today, more or less, right? And a USB 3 someday will be able to do that again. Okay, so in order to be able to manage the flash well, we took our software, which lets us use these in failed systems, and made a USB device. And that's the first thing we're doing first. And then back to remember I told you this SSD there are 8 of those in the SSD in order to be able to run at SATA speed. And then there's a management that does the SATA and another management that runs DRAM. And what we're doing is our interface is all DRAM based, not flash based. So it's much faster and it has no errors. And whereas even the Mac today, which has lots of time to wear out the disk, because if you're going to do snapshot, they wear the disks out. So an Apple will last maybe a year and a half before they have to put another disk in, another flash drive in. And whereas in ours, we have a patent that keeps us from ever wearing out the disk, and we're full SATA speed read and write.
So you even solved the problem of flash drives while wearing out and getting
gone. I've taken it away because I'm doing my computer. The SATA interface is running with DRAM only. And DRAM doesn't wear out, right? Your DRAM that's in your machine is being refreshed you know that DRAM is a dynamic device, and so it's constantly being refreshed. So what would be give you wear in a flash, which means you're writing and reading it again. In a DRAM, you do it all the time anyhow, right? So DRAM doesn't wear out, and so we only go to the flash. We only put stuff in flash when it's done being updated.
So, which part of your working history did we miss here? I think
Oh, you
there's
missed
a
it. So
lot
you
more.
missed that. You missed the Commodore. The time we were at Tandon, because we went into the market with a 286 machine when 286s were just taking off, and we set a price point for 286 that nobody else had, and so we were able to get market penetration. And then
286 was the PC generation, right? You mean the
PC started off with 8088.
Yeah, and then you
Okay.
286.
And yeah, the 286 was the first one that let you do multitasking properly, right? And you could get extra memory, right? There was a thing called a above board and above, but fundamentally the PC model was built in for 1 megabyte, right? And the 286 was the first time that you went up. And then the 386 was just a faster 286, right? And they did a thing called a 386SX, which was a lower version, but still had the functions of the SX. And the SX was truly a multitasking operating system. And, now Intel has, I don't know what level they're at, but, fundamentally from the 386 up, 46, they were doing better multitasking.
So you worked in that area too?
Oh no, we were second supplier in Europe. We built the company up to the point we were the second player in Europe. The problem is that the owner of the company decided that he wanted to run the memory computer business because we sold the disk drive business, and he wanted to take over running the computer business. And he did it at a time in a way that caused him to lose the company. So lost two, right? I didn't lose that one. I was gone. Then our company that did the DRAM, we got into trouble with that company because all the semiconductor guys quit selling partial DRAM because they were having a problem with amount of supply, so they cut us down and they took our 3,000 people factory and shut it down in 2 weeks.
So you changed companies pretty often in your life.
Well, actually, the company that was doing all of this DRAM stuff and everything else is my company, and we did partnerships. So I've owned the technology that I came up with, the patent that let me use DRAMs and everything else, since 1989. So the same company's been there. The same company, we're going to be using it again. All the patents are in this Bermuda company. And so it's the same company, it's just different partners. And we're out seeking financing right now to get to the next phase. And I want to get partners with a couple of the big big PC suppliers to make this change back to the point where you've got a PC. And I've actually submitted plans to Microsoft, who's jerking around with them, and I've actually submitted a plan to Google to replace Microsoft because the market, there's 1.5 billion people out there that want an upgrade machine, and they're not buying them because what you can buy now isn't an upgrade.
You consider flash drive, so solid state disk nowadays not an upgrade?
Right. Solid state. Right.
You don't consider that appropriate upgrade? You think?
Yeah, the flash drive. If you look at the flash drives, if you're using them to just do program load and everything else, they're perfect. Because of the access time, right? If you want
instantly fast, I can put up my PC within 5 or 10 seconds.
Yeah, that's what I'm saying. Because you get instant access to the read, right? Yeah. The problem is when you start writing them, they're very slow, and they've got lots of problems writing them, right?
That's true.
You have to write 256 pages at one time, and people don't take that into account, right? Not only do you have a slow write, which is necessary because of the physics, right? But you have to catch all of the rest of the block up because you can only change a block. That's where the wear comes from. You can only change blocks 1,000 times, right? And you have to update the block. When you make one change, you have to update the whole block. So it's got
cluster block.
Yeah, and I solve all those problems with my new design.
So you will have a product on the market that is way better than solid state disk.
It's a solid state disk, and we'll build a new PC around it with the new software and the, you know, not me, but I'm going to
Your
go. To,
team,
I'm
your
going to
team.
go. No, I'm going to go to people like Lenovo and HP and those guys who already have market share and distribution and everything, and just give them the ability to do this because I want the PC to come back. I don't want the PC to go away. Right? Too much to build it, right? And there's no reason for it to. We proved with the hard disk, we proved at the beginning, the hard disk is so important, and they just lost focus, right? You
And you are
need the
picking
fact,
up again, and you are driving this
yeah,
further
yeah,
again.
yeah. Because I want to be back to, as you said, you can fast load. You're very happy, but you can't do anything else with it, right? The
Well,
SSD is,
I mean, the problem with SSD drives is there's a lot of failure. You actually have
yeah,
a part of the disk that is only reserved as a backup for the
yeah,
damaged clusters
yeah.
that is appearing after a while. So that's
You see,
basically
I
the
don't have
problem.
those problems
That's pretty good.
because of my patents.
So let me ask you, from the perspective nowadays, are you happy with how things developed? I mean, all the things that you foresaw in the past, in the 70s, what will happen? I mean, even I have a second computer, an iPhone.
Yeah, you have.
Are you
But
happy with the
no, no,
development?
no. By the way, no. The iPhone is really not a computer. It's like calling a calculator a computer. It's really not a computer, but it's a very nice device to do what you want to do with it, right? I mean, you can take great pictures with it. You can share files. You can text. You know, you get a version of email, right? If you want to do real emails, doing it on your iPad's not so. I mean, on your computer's not so much fun, right? So it's better than a watch, right? It's better than a calculator. And they call it a smartphone, and it's a new market, right? And it's created a new market, and everybody has to have one, right? And I have one, right? It's the only Apple product I own, right? And I got the Apple product for one reason. Jobs, when he came back, he gave a bunch of guys a free hand, and they've got patents on the way the screen works that
The
nobody
touch
can
pattern,
match.
yeah, the
Yeah,
multi
being able,
gesture stuff.
well, yeah, but being able to move around and everything else, try it on a Samsung, or try it on another and your iPad. The iPad is just superior because they've got these patents on the way
Yeah.
the screen works. And I was refused to buy an Apple product and all this thing, so I bought iPads for my grandson and my partner, right? And I bought a Samsung, and I got so frustrated with using it, I gave it to one of my other grandsons and went out and bought an iPad. And since then, I just stay with only have iPhone because of that superior screen, right? And by the way, it was a really good move, right? And
So
so they made it. By the way, apparently everybody says it's not as good as the Androids, but I don't care because what I'm doing with it. I want to be able to have the screen work well.
I mean, the problem is with Android from my personal perspective, because I had an Android phone. I had an Xperia X10 for a year.
Yeah.
That is, it's really for geeks. You can, well, you can root it. You can put a custom ROM on it. You can spend your whole weekend tweaking the machine and
Hey,
making it
back to the
better.
kit computer, right?
Yeah.
That's what people were doing with kit computers, right? They
Yeah.
By the way, a market that I'm really happy with that you asked me about developing, which development. I think what Corsair and these guys have done with making computers really great game machines, right? They if you buy a Corsair machine, it's really not much of a PC, right? I mean, it's got its own fast processor that they're cheating on. It's got its own keyboard. It's got its own disk. It's got everything, but it runs the games that people want better than anything else, right? That's really a targeted application. It's done very well, and it's taking the technology to a place which these guys, I know the guys at Corsair, they're really sharp technical people, and what they've done is they've taken this narrow market, right, and done really wonderful things with it, right? So that yourself, there's a set of gamers out there that don't care what they pay for their computer, right? They absolutely do not care. They
The
want the
power users,
fastest.
power
They want,
gamers.
they
Yeah.
want, they want, yeah, they want the best because they're playing the games that are so interactive and so, it's like it's like going into battle with a machine gun or a pistol, right? You need the pistol, and so that's a nice thing, right? That's a market I'm really pleased with, right? That it happened, right? And of course the fact that everybody does their taxes now on the computer, and almost every business has its computer. All of those are really good things. I'm really happy they happened. You asked me, was I pleased? I'm really pleased that all of those things happened. That the computer made their life better and easier, right? The game guys made it more fun, but the stuff they're doing with the computer, and then you listen to people in a call center or something or other, and the computer gives them some trouble, and they sit there and complain about it. Well, they got a computer they didn't have before, right?
Yeah.
So I'm really proud of that, right? You get on an airplane and everybody takes their laptop down and starts putting it on the desk, and so there's an entire airplane full of people using my computer, right? So not. I'm happy with it. I'm just sorry that Microsoft got lost. Okay.
So, do you consider yourself actually a very important pioneer person? What is your own perspective about yourself, what you have achieved in your life?
Well, I think there's no question that we created the market for low microprocessors and how people use. The fact there's a microprocessor in everything, right? And 10 of them when you have an operation and so forth. I think we created that, right? I mean, I'm going to take credit for that. We put it out there, made it happen, right? We didn't follow up on it, right? But we definitely made it happen. And I think the computers, there's no question, all the way through the 664, we had machines that made people computer literate, and our MS-DOS machines and our data pack machines and so forth made people, and putting the hard drive on there really made a difference. And so I think my teams that I had, in each case I did these with teams, right? And I did change the world several times, right? And so I'm proud of that.
So let me ask you one of my final questions, because I asked that everybody I interviewed so far. What do you think is the next big thing? Because I was speaking to Michael Tomczak 2 years ago, and he was saying the next big thing, that next big hype is more advanced smartphones and smart devices. While Bear, who had his part in inventing home video gaming, kind of, he said the next big thing is interactive television. What do you think is the next big invention that is coming to us?
Oh, it's robots. Everything that has to do, I don't know if you've been following what people are doing with robots. You can take a robot and send it to some place and make it do an operation, right? By just talking to it and explaining it to it. The technology that's going into there, and by the way, they're using lots of microprocessors, right? But right, but the point is that is a absolutely market with no end, right? And I don't know if nanotechnology is really going to work and take off, but if it does, it's the same thing. It's more distributed intelligence, right? It's taking a robot and putting it here and having a doctor here and talk to it. That's distributed intelligence. Remember I talked about distributed intelligence? I think that's still happening, right? It's happening in new ways, right? So people talking about nano robots that take over your body and clean it up and everything else like that. Those are distributed processes. All those little guys, So I think they're outgrowth of where we are today, but I have great hopes for them. I know robots is going to go, right? No question. I tell people that when the kids are coming out of school now, I tell them go into robots, right? Because it's such a tremendously open market now, right? The things they're doing are wonderful, and we'll look back at them and think how primitive they were, right? We're at that point, but. And we're not talking about robot fighting and all that stuff. I'm talking about real people using real robots for all different kinds of things, right?
Household devices, in medical, micro robots.
Yeah, but robot surgery. My brother had his prostate done with robot surgery, right? It's coming. It's there, and good, right? I think that's great.
Aren't you fearing that there might be a point where robots are getting dangerous, or computers are getting dangerous?
Let me make a point. I'm a programmer. You programmed, right? Tell me how a dumbass machine that you have to tell had one and one together is ever going to get smart. Seriously, people keep forgetting the fundamentals, right? This thing is very smart because we put a lot of software on it, right? But it's so people are talking about AI, right? And
That's what I'm
and
talking about. Yes.
we're flying airplanes with AI and everything else. But if you look at it, they're really task processing in a funny way, right? And so when I talk about building robots, I've been telling people for years I'm working on robots, and what I really mean is smart computers, right? Computers that do things that you didn't do before, right? Whether it's a spreadsheet or a better or flying a better airplane, right? That in each case, what it is you've taken some experts, right? And those experts have made it good doing that thing, right? But do you honestly think that the AI in your airplane is going to come back and start dropping bombs, right? The answer is not a fucking way, right? There's no way from here to there, right? Hal was funny, but it was not real, right? You can't make a computer that wants to wander away from itself, right? Even though you try to make it do it, right? They aren't smart enough, right? I think honestly, they just aren't smart enough, and I don't care what you're doing is you're putting better software on, you're putting better, make the hardware a little bit better, but it's still back to it's a binary system. It's got a microprocessor. It might have 50 microprocessors all doing something, but they're all still adding one bit to one bit, kind of thing. It's just not happen, not gonna happen, can't happen, right? They do you fear computers? No.
No, I don't. But do you
And you
think?
fear robots? No.
No,
I mean, the answer is you could make a robot that was really bad, right? I mean,
of
you
course.
could actually spend the time. You could, we spend robots. I don't know if you watch how the military's done robots, right? Did you
Yeah.
did you watch the movie about the guy who was blowing up things with his robot? What was it called? The Hurt Game or something like that? Uh, Hurt
Could
Locker.
could be,
Yeah,
could be. Yes.
yeah. Anyhow, it was a very famous movie, won Academy Awards and everything. What they're doing is they in order to get these bombs going up, they send this robot down, and the robot picks up the bomb, blows up, the robot blows up, and they get rid of the bomb, right? And all of the bomb squads around the world now have robots that they send in, so that people don't have to get blown up, right? And so we're using robots in a whole bunch of really smart places, right?
Yeah, true.
But they're still doing a job, right?
Yeah.
So there's no question I could make a robot, strap an atomic bomb to its back, right, and
Cool.
send it in under somebody's place, and it would do terrible things, right?
But it would not
But
do it by itself.
it's not the robot that made that decision, right? It was a whole bunch of people that made this. I mean, look at the airplanes, right? We took a beautiful device like an airplane and let some guys turn it into a bomb, right? And it was a very effective bomb, right?
It works.
Really
Yeah.
effective. Yeah. And but the point was, does that mean the airplanes are bad?
No,
No,
of course not.
right? Not at all, right? It just means that bad people can do bad things with things like that, right? And yeah, yeah, no, I don't think there's any issue, right? I really don't. I think there'll be bad people using robots and bad people using everything, right? I mean, but they're doing it the same way we use them, also, right? They're bad people who want to do something in a bad way, right? I'm just trying to think.
Speaking about the marketing guys, tomorrow I will talk to Petro Tichenko, actually, who was international marketing guy of Commodore Germany.
You
So,
work for Spire?
I think so. I'm not really sure.
Yeah, find out, because Spire was far and away the important guy for Commodore for a long, long time.
But Petro did the deals with Ascom and so on, this and Gateway, to keep the Commodore and Amiga trademarks alive here in
Yeah,
Germany.
after Commodore lost him?
Yes, because
Okay, then so he picked up and carried on
Yeah,
Commodore afterwards. Okay, yeah,
yeah,
he
yeah.
wasn't part of this, right?
After 1994, he
Yeah, yeah,
picked
yeah,
up Commodore and managed further.
yeah.
So
I
tomorrow I
I
will talk to him.
actually think I met him because we think we talked at one time or another. But yeah, they no no they, but and yes, there was. I mean, I can't possibly have named all of the important people, right? Okay, yeah. I think I mentioned Bill Davidow, who created the 8088, which is one of the key breakthroughs for MS-DOS.
Mm.
Gates, of course, talked about him a lot. I'm going to tell you my famous Steve Wozniak story. A couple of them. He and I went gambling together one time.
Oh,
Uh,
okay.
and so I like him. He's a good guy. But I tell everybody when I was at conferences and everything else that Steve is such a different guy than everybody else. The the video games, when they first were doing all the video games and all these other games, every game except Night Driver was always about violence, right? Pong, back and forth. Everything had some kind of, and was, in order to fund the Apple, created a game called Breakout,
Ah, okay.
and Breakout was a non-competitive, non hurtful game, and it shows who Woz is. Right, that's who he is. A very nice person who really didn't see himself as doing a tank or anything like that. He was doing this game that was fun to play, but wasn't making anybody feel bad, right? Yeah, and that's who Steve is, right? And so if you talk to him again, I've complimented him about that every time, right? He's gotten credit for doing some stuff that he never did, but he certainly had that thing about him where he was this peaceful, nice person. And so I hope you can get to him. No, I don't have any contact with him at all.
It's really hard to get through because press his press department is keeping him away
Oh
from
yeah,
the
well
show.
that's I can't even reach Gates, and Gates and I had some really famous arguments and discussions, and we talked and everything else, but I can't reach him anymore. He's
Yeah,
Phil.
that's also the thing I wanted to ask you about. On the website Commodore.ca, there is this history blog about who created Commodore computers, Atari, Amiga, PC, and there's also your name for Commodore, obviously. And he's the webmaster of that page. Said he met you once on a fair, and you made the statement that there's nothing nice about Steve Jobs, but actually Bill Gates is not such a bad guy.
Yeah, I, my partner really gets mad at me because I said that about Steve. Because at that point, Steve was really being obnoxious, right? I mean, he got rich and was carried away with himself, and it was really true that he was doing a lot of stuff that. And if you talk to people, you'll see that he was doing a lot of stuff. And what happened to him is he got married and he got the illness, right? He had a couple of bad illness, and they changed him to being a more human person again, right? And I think Pixar probably helped him a lot too, right? I mean, Pixar was a totally non-confrontational device thing, right? And just did great. So I think to some extent he got mellowed, if you will. Gates was getting, during that period of time, the reason I said that is there was this movie that was effectively about Gates, even though they didn't say Gates, right? Remember, there was a movie that showed him as an evil person.
Silicon Valley story. That was the movie
Yeah,
you were talking about.
there were a couple, yeah, and that really made Gates look bad. Well, there's another one too that was even worse, right? And
Yes, that was a Jobs movie that was released a while ago. That was two.
no,
That's
no,
actually the two member.
um, so people were bad mouthing Gates much more than he needed to be bad mouthed. He actually Gates was a very successful businessman because he had guys like John Shirley with him. Okay, and because of that, he was very successful. Okay, but that didn't make him bad; it just made him successful. And like they went in and they literally beat out the kid that started the Netscape, right? But they beat him fair and square. They didn't do anything dirty. They just, I mean, with all due respect, Excel replaced Lotus, right? Didn't badmouth Lotus. They just beat him, right?
Mm.
So Gates has beaten a lot of people, and he always got a reputation because he was beating people Andresen was the worst one to beat because Andresen was younger and, more of a star. But the point was that Gates didn't do anything. I don't think Gates does anything bad ever. I've been never able to find anything bad he done.
So is there anything I missed in our interview that you would like to add?
No, I think I want to make sure that I give credit. Let me just make sure that I've listed at the end the guys who made it all happen. There was Dr. Roger Camp, who supplied all these people, right, from Iowa, and he actually worked for me later. John Fagans, who was from Iowa State. Seiler, who came from Florida, right? Fujiyama and Algae. Yaz Terracora, right? The Trammell for obviously helping to fund all that. Andre Suzanne, who really helped us get started and helped the whole industry get started. Scott Patterson and Glenn Stark, who did the disc stuff and who followed me through multiple companies, and we did all this really good stuff with discs and removable drives and everything else. They're really good guys. Make sure I haven't forgotten anybody. There was a guy named Bobby Taylor who's caused me a lot of trouble in my life, but he was really important at doing the Victor machines, right, and the Sirius machine. Phil, the guy just got killed, who was in the room when they screwed up the deal with IBM. What the hell's Phil's last name? But there were a few people along the way. Dick Bugatti, who did help me do 3 or 4 different companies, who's unfortunately is dead. Peter Sonnell, who without whom we wouldn't have got the 6502 done, and we wouldn't have got the PAT done, and we wouldn't have got the Victor done, and everything else. A really important guy. Dave Marconi, who did the designs on all of our stuff, right, and really ultimately went on to designing a lot of the Japanese stuff. What else have I missed? I told you about Spire. Kit Spencer from England, who helped make the Commodore.
Commodore UK.
Yeah. He was more than just UK. He actually went down to Bermuda and ran the company from Bermuda for a while. Chris Fish, of course, who started Victor and helped me with Commodore, and it was a really important guy. John Pavin, I already mentioned. Don McLaughlin, who invented the KIM, right, and the concept of the RAM-ROM IO chip. Tom Bennett, of course, I mentioned. Bennett was the guy that started microprocessors at Motorola and drove them, right? Never got any credit at all for that. Just trying to think of people that I might have missed along the way that were really important. Peter, I talked about. I'm sure I've left somebody out, and if I do, I apologize for that, right? I had some good marketing guys for me at Victor and good marketing guys in other places. My team in Europe that we kind of went through Victor and so forth, Jürgen Tepper and Jamie Minato and the guys down in Spain, who I'm going to get his name in a minute, Roberto, were very important because they were not just marketing guys, they were actually building companies, right? Jaggy Tannen, who has caused me more trouble than anybody and also made me more successful than anybody, so we'll mention him. His brother, Dr. Tannen, helped us a lot with this last set of companies. Yeah, those are the people that made this thing that we talked about work.
Great.
Harish Grover, who worked with me at making this last company work and has gone on to make a nice, successful company selling.
Well, thanks for doing the interview.
No problem.
I wish you good luck with your plan.
Okay. So anyhow, Wiedersehen.
Okay.